Finally, yes, I'm live. So, good evening, good afternoon. Wow. I mean, I always make this timing, wishing time error at my end. So, hello, guys. Hello, NEET warriors. How are you? Hello, Earth, Mr. Pathak, Mr. Hama, Ananya, Ikra. Good afternoon. How's your study going, beta? Pathak ji, welcome back. Now, Pathak ji, I guess as communicated, I have especially read you have put in a very elaborated comment that you want physical. So, physical I have completed. Yes, three chapters: solution, electrochemistry, and chemical kinetics. As promised, I'll be coming on Sunday, and we'll be discussing the relevant questions with the 500 questions marathon that we have on Sunday. So on chemistry part, we'll be doing the physical chemistry because those three chapters: solution, colligative solution, the colligative property area, and good afternoon, beta, and electrochemistry and chemical kinetics. I'll be coupling it up with some questions of thermodynamics also, because I remember with my previous physical live, the thermodynamics, I guess we have just started with one question, but we'll be discussing somewhere around 15 16 questions more from thermodynamics. And those are beta, you have to understand one thing. The paper will be very traditional, and therefore whatever you have your basic concepts of chemistry, physics, botany, zoology, so coupling up all of them together, beta, it becomes a huge packet. And what you should focus on the frequently asked topics, that is what I'll be doing with today's live. Now today we'll be discussing complete inorganic. How I'll be structuring the inorganic is, first we'll be discussing periodic table, and not just periodic table, we will be coupling all the block chemistry logic. So we'll directly go to D block elements, because ultimately NCERT has omitted P block and hydrogen family and all the S block elements detail. What they have found interest in the DNF block. Even JEE Mains has done that. So what we'll be doing, what we'll be focusing in, is all the concepts today in today's class. So yes, today's class will be somewhat around 4 hours. So but I'll try to bring it so precise, because I know after studying beta you have to revise. So make sure after this live you go and download these notes from PW NEET English WhatsApp channel, practice them once, and have a revision beta, maybe with a 2x speed, but have a revision of these topics also. Chalo. So I hope everybody is charged. Sir, your strategy is good, sir. Okay. So thank you, beta. Chalo, beta. So welcome, Henry. Welcome, Rolex. Welcome, everybody. Let's start. Now, we will be first starting with the periodic table, the modern periodic table, and we'll be structuring this modern periodic table. So first, the beginning of the class, we'll be dealing with a bit of theory, because yes, inorganic is nothing but a huge packet of theory. So let us understand that theory conceptually. So moving forward, whatever atomic structure we know, the quantum theory has categorized that the distribution of electrons will be strictly in accordance with the Aufbau principle. That is, that orbital which is that subshell which is of minimum energy has got highest stability to it, so it will be filled first. Post that, as the energy increases, the building up takes place and the higher orbitals, higher subshells are filled. Now, if a subshell has more than one orbitals, those are of similar energy, that are called degenerate orbitals, then those degenerate orbitals are filled in accordance with Hund's rule of maximum multiplicity, as in you fill them you make those orbitals singly filled, and after that, after filling them singly, you make them, you pair those subshells, you pair those orbitals. And last is Pauli's exclusion principle, which says that you should fill only 2 electrons. So as per that, in accordance with that, the modern periodic table is also conceptualized, where hydrogen being the first element. After that, the alkali metals, hydrogen is a first group 1 element but not an alkali metal. So after hydrogen, what comes is lithium, As in the rhyme, the famous rhyme. I know you, most of you have a mnemonic by yourself. If you do not have any mnemonic, let me help you with it. So hydrogen, not an alkali metal but a group 1 metal. So है ली ना की रब से फरियाद, as in hydrogen, lithium, sodium, potassium, rubidium, cesium and francium, they constitute alkali metals. But yes, because there is hydrogen also, so I'm not making it alkali, I'm writing it group 1. Group 1. So what will be the general electronic configuration, beta? Sir, it will be NS1, where N belongs to the period number, and as per quantum theory also, the filling is taking place. That is the perfect obedience of Aufbau rule is taking place with our periodic table. Now, after that, the alkaline earth metal comes, who are having their valence electronic configuration as NS2. Beta mange car scooter bap razi, as in beryllium, magnesium, calcium, strontium, barium and radium. Now, one most important thing is beryllium is not regarded as a alkaline earth metal. Why? Because all these metal forms oxide and hydroxide, which are definitely basic, but beryllium is an amphoteric oxide and therefore it is not regarded as alkaline earth metal. Together they constitute the S block. Why? Because the last electron is going into an S subshell. So together group 1 and group 2 constitutes the S block elements. Don't worry, beta, I'll be going with complete basic, but yes, we'll be practicing questions also after the basic structure we have done. I'll be including chemical bonding basics in this also, so don't worry. But yes, please sit with your pen and copy, because this lecture of mine, these 3-4 hours of ours, will be making at least 15 to 17 questions of your NEET chemistry. I am telling you that. But yes, please keep your pen and copy intact. Don't try to write anything as of now, because definitely you can get these notes once the class is done, free of cost, from our WhatsApp channel, which is PW NEET English. Or if you have subscribed for the RE-NEET test series, then obviously this will be provided in the app. Chalo, moving forward. Now, sir, after hydrogen, what is filled? Sir, helium. So after that you have helium. That is 1s1, this is 1s2. But helium is not regarded as an alkaline earth metal. Why? Although the electronic configuration is 1s2, but because of its chemical inertness, it is not at all reactive. It is separately put in a group 18 element. So this constitutes your group 18. Now, after beryllium, what you have? So boron, carbon, nitrogen, oxygen, fluorine, they constitute 2s2. This is 2s2, 2p1. Then it is 2p2, it is 2p3, 2p4, 2p5, and ultimately last we get our inert gas, which is nothing but 2p6. So make sure you are revising atomic structure also with this. Now, neon is atomic number 10, sir. After 10, what you have? Sir, sodium and magnesium in the S block. Then you should learn the P block elements starting from boron family. So Began, Alu, Gajar, Inthela. I'm leaving this. I'll be giving the mnemonic of these elements also, because your NEET examination definitely is very much interested in the symbol. So we'll be learning the mnemonics. So first, not the radioactive ones. So till helium, Began, Alu, Gajar, Inthela, as in boron, aluminium, gallium, indium and helium. I hope everybody is clear. Now after that, sir, the carbon family, which is Kashi, Gaye, Shankar, Parvati. Now let us do the general electronic configuration for boron family, sir. It will be NS2, and after that NP1. Sir, it will also be NS2. After that it will be having NP. After that it will be having NP2. Similarly, this will be NP3, the half-filled configuration. This will be NP4, this will be NP5, and last is obviously NS2, NP6, which is for inert gases. Now, sir, nitrogen family, New Zealand, Pakistan, Australia, sub Bicau. New Zealand, Pakistan, Australia, sub Bicau, as in nitrogen, phosphorus, arsenic, antimony, and bismuth. After that, the oxygen family, Us se tipo, as in oxygen, sulfur, selenium, tellurium, polonium. After that, the halogens. Now, because halogens are so important, therefore I do not ask you to learn any mnemonic, just learn them by their names. So fluorine, chlorine, bromine, iodine, and astatine. Astatine, as you go down the group, the metallic nature increases, and because of increase in metallic nature, we technically do not consider it as a halogen. Moving forward to the inert gases, so hai na agar kar zero run pe, so that they constitutes your basic inert gases, as in these elements do not react, and because of their chemical inertness, they are separately placed, and whatever basic periodicity we learn, that periodicity only extends till group 17. Why? Because what is the basic periodicity that we remember? Sir, basic is everything is dependent upon atomic size. Sir, we remember, you must have seen a film that a student has learned an essay on cow. So whatever essay is asked, he relate that essay with the essay of cow. Like for example, he is asked in the examination that what is aeroplane? Write an essay on aeroplane. So he has written that I was flying on an aeroplane. I saw down in the hills. I saw a cow, and the cow has two to four legs, two eyes, and whatever. So this is the same logic that we apply in periodic table also in complete inorganic. Atomic size periodicity you should know by heart. Sir, atomic size increases down the group. Why? Because number of shell increases, and from Bohr theory we know radius is n square. Radius is proportional to the square of the shell number. So sir, down the group size increases. Now why there is huge increase in size? Sir, because inner shell electrons also act as a shield between the nucleus and the valence electron. If you are the valence electron, the student sitting at the back, if I am the nucleus, the teacher, the more number of students we'll be having between us, the lesser we can interact. So therefore, the effective nuclear charge which is felt by the outermost electron is not the number of protons attracting. It is number of protons attracting. Therefore Z effective becomes, Z effective, which is the effective nuclear charge, becomes the nuclear charge minus shielding. The shielding is provided by the inner shell electrons, and the maximum shielding is of whom? Sir, maximum shielding is of S because of the symmetrical shape. It is quite symmetrical, and therefore it shields to the maximum extent. Post that, P and D and F do not have less shielding beta. They have so poor shielding that their shielding is not at all considered while doing the Slater's rule. Now, that Slater's rule calculation is nowadays even not applicable in advance, but at least you should just learn this much, that S and P, S has highest shielding, P has less shielding than S, and D and F orbitals are so diffuse that their shielding is almost not even considered, and because of that, the Z effective increases to a highest extent. We'll be taking the applications of this poor shielding of DNF also. Now, coming back to the periodic table. Perfect, guys, perfect. Coming back to the periodic table. After calcium, which is obviously 20, from fourth period, the filling of D subshell starts. Sir, calcium is 4s2 because fourth period, so 4s2, but the D will be 1 less because it is starting from fourth period, so it will be 3D, just in accordance with Aufbau rule also. So after calcium we have scandium, titanium. What is the rhyme? Shakti Walker, as in Johnny Walker, you know? Yes, the brand. So Shakti Walker. Man as in heart, fe ko ni. You throw that heart. We anyway throw around our hearts everywhere. So man as in your heart, fe ko ni. And if you throw something, that thing gets swelled up. So in Hindi we say suj gaya. So it is Sujan, Sujan, Su as in copper, Jan as in zinc. So this is from till atomic number 30, and scandium starts with atomic number 21. But how the electrons are filled, beta? So this will be 3d1, this will be 3d2, this will be 3d3, and obviously I'm not writing that. I'll be discussing the electronic configuration separately, and ultimately it will be 3d10. Sir, after that, what is filled? Again, now this becomes your 3D series. So after that, what you fill is your 4D series. But what is the mnemonic which you should learn? How you should learn this periodic table? I make my students learn on the pattern zinc, cadmium, mercury. Zinc, cadmium, mercury. No rhyme. Zinc, cadmium, mercury. Why? Because what are D block elements? Sir, when your last electron is entering a D subshell, it is called a D block element. Perfect. All D block elements are regarded as transition elements. True or false? Sir, false. Only those D block elements are regarded as transition elements which have at least one unpaired or empty d orbital either in their valence, either in their ground state or any of their oxidation state. Like I am forming a compound, I must have at least one d orbital which is either not at all filled or partially filled, so that the d electron transaction can take place. And whenever d electron transaction is taking place, it is reacting chemically, then only that d block element is regarded as a transition element. And because zinc, cadmium, mercury has got no empty or partially filled d orbitals, neither in their ground state nor in their any oxidation state, because they generally show compounds in +2 oxidation state. And in +2 oxidation state, they have all filled d orbitals. So because they lack of d orbital participation in chemical reactions, therefore they are not regarded as d block elements. Moving forward, after that, what we learn? Copper, the coinage metals, copper, silver, gold. How to remember it? Which is cheaper? Silver. So copper, silver, gold, copper, silver, gold, copper, silver, gold. And many students always forget this. What? After nickel, at the bottom, what comes? PDPT. PDPT. Why? How to remember it? D alphabetically comes first, T alphabetically comes later. So nickel, PDPT, nickel, PDPT. So these blocks, these groups we have studied independently because they are very much used. So you should know them by this trend, or if you know some mnemonics, it is good. But if at all, as we promised, we are there for all the students, whoever are maybe getting 20. If already you are scoring good, that means you are in the top 1 lakh. If at all you are in top 1 lakh, then you must be trying to maximize your marks. Then for that also the revision will be helpful for you. And if at all you were scoring higher from the range of 1 lakh, but still we have 20 out of those 22-23 lakh students appearing for NEET. What about the other 21 lakh students? So here we are making those students also count, and that's why I'm keeping everything with the basic. Now after that, sir, after that, this 3D series, after that you should know the 4D series. Now what is that 4D series? The mnemonic: यारी जरा सी निभाओ मौत तक, यारी जरा सी निभा मौत तक, रुकावट राह में. After that पड़ी है. So after PD, palladium, you already know. So again, यारी जरा सी निभा मौत तक, रुकावट राह में पड़ी है. This constitutes your 4D series, the second transition element series. And post that you have lanthanum. Now sir, why lanthanum you have done with a separate color? Because beta, this is 6th period, so they will be 6s2. After that, as per AFBAU also, after 6s2, 4f must be filled according to the n plus l rule. But only this lanthanum with atomic number 57, with atomic number 57 is filled first. So it will be 5 because this is 6s2. So this will be 6s2 5d1. Although after 6s, as per above, what should be filled? Sir, 4f. But 4f is filled after the filling of lanthanum. Similarly, in the 7th period, it will be 7s2. What should be next filled as per above? After sir 7s2, 5f must be filled. But just the one element, which is actinium with atomic number 89. So this will be 7s2 6d1, and definitely after lanthanum the 14 lanthanoids are filled from 4f1 till 4f 4f14. Obviously, because this is 57, so this 4f will be 50, 4f1 will be 58, and 57 plus 14 makes it 57, 67, this makes it 71. Again, after actinium, the actinoids are filled. Again, for actinoids, they will be starting from 5f1 because this is 89, so this will be 90, and 89 plus 14 is 103, so this will be 103. Again, the actinoids and lanthanoids, their mnemonics also we'll do. Now, after the filling of lanthanoids, the 72nd element comes here, which is HF, hafnium. This is 72. So this will be 6s2. After 6s2, I have filled this 5d1. After this 5d1, I have filled complete 4f14. And now that 5d1 will be again filled with the another electron. So it will be 5d2. So this is of HF, which is hafnium. So what is the rhyme for, obviously, what subshell is filled? Sir, 5D. So they will be the 5D series, the third transition element series. Now, what about these third transition element series, sir? What about the mnemonic? La hafta, give me money. ला हफ्ता वरना रे उसधर इधर पीटूंगा. Why I am saying usdhar as an os, osmium. Why I am saying irdhar? Because it is ir, iridium. So again, la hafta varna re usdhar irdhar pītunga. I hope I can do it. Now, after actinium, what you should have, sir? The 6D series in the similar fashion, sir. Now, what about this 6D series, sir? Acha Raftar, you must have heard about that singer. Acha Raftar, dubbing and singing. BH as in बहुत हंस के करता है is just a mnemonic. करता है as in he is doing is just a rhyme to remember. So again giving you the rhyme. अच्छा रफ्तार dubbing singing बहुत हंस के करता है. Now, do not give him. In Bihar, we say mat des. So mat des, do not give him. What do not give him? The singers generally keep on hitting and playing music with whatever articles you have. So there are some rugged cones. So rugged cones, they start making a good healthy sound with those rugged cones. So rugged cones. Again, this is a mnemonic which I have used, and these mnemonic has been given to me by one of my students long back in the year 2013. So I do not know, but yes, because of some synchronization, I just love that mnemonic, and since then I've been using the mnemonic from that student of mine. So this is अच्छा रफ्तार डबिंग सिंगिंग बहुत हंस के करता है मत देस rugged cones. So this constitutes your 6D series, and after the 6D series, this completes your periodic table. But sir, in your JEE examination also and in your NEET examination also, you should learn at least the symbols of lanthanoids, actinoids, and these p block elements which are radioactive. So let me move to the mnemonics for lanthanoids and actinoids as well. So for lanthanoids, we have it starts after lanthanum. The first filled is 4F1, so that is cerium. So what is the mnemonic? Seena par nadiyan PM ki samai, because these days people are in love with PM, so I say PM. So सीना पार नदियां PM की समाई यूं गदगद तब दिल ये my heart दिल ये हुआ because it is HO अरे इरिडियम तुम ये भी वाई भी ये टर्बियम लूट लो ल्यूटिटियम. Again giving you the rhyme. सीना पार नदियां पीएम की समाई यूं गदगद तब दिल ये हुआ अरे तुम ये भी लूट लो. Now these mnemonics I am giving in my native language only, beta. Why? Because obviously you should always have a rhyme or mnemonic which is quite in sync with you. So if at all you have any other rhyme, but beta, please remember the symbol, the elements symbol along with the position, because that will be helping you to determine their atomic number and electronic configuration. So this cerium will be 4F1, this will be 4F2, and obviously lutetium will be ending at 4F14. So they constitute your lanthanoids. After that we have your actinoids. So what is the rhyme for your actinoids? So after actinium, which is atomic number 89, which is atomic number 89, so this will be 90. Now what is this, sir? Thorium. What is the rhyme? थोड़े पहलवान उनसे निपटेंगे. Some of the bodybuilders will deal with those people. So थोड़े पहलवान उनसे निपटेंगे. पुराने आम कम बिकेंगे. पुराने आम कम बिकेंगे. Again breaking the mnemonics in halves. So थोड़े पहलवान उनसे निपटेंगे. Another thing. पुराने आम as in old mangoes कम बिकेंगे will be sold to a lesser extent. After that कैफे में CF, कैफे में कैलिफोर्नियम, कैफे में ऐसे फरमाओ मैडम, कैफे में ऐसे फरमाओ मैडम as in मेंडेलिनियम, नोबल नोबेलियम, लाउरे लॉरेंसियम. So लाउरे, again giving you the rhyme. थोड़े पहलवान उनसे निपटेंगे. पुराने आम कम बिकेंगे. कैफे में ऐसे फरमाओ मैडम as in मेंडेलिनियम, नोबल, लाउरे. These constitutes your actinoids. Now moving to the name, because I guess since NEET 2024 they have found interest in the names also, in the elements which have atomic number more than 100. Sir, but we already have an IUPAC naming. Yes, we do have. We name the digits 1 2 3 4 5 6 till 0, and we add a suffix IUM. I hope that everybody will knows. We'll be doing question also on the basis of those IUPAC mnemonics, but you should know the name also. At least you should know the symbol of the elements with atomic number more than 100. So already, sir, you have given us the rhyme. So again, let us revise that rhyme from 101. So from 101, this is Madam, Noble, Laure, Lawrencium. After that, sir, we need in continuity. So after 103, you need to know 104. So on the basis of periodic table, we have already done it. But let us couple it together for elements with atomic number more than 100. So Madam, Noble, Laure. Now what I have done is the LR represents the symbol, so that is different colored. So the rhyme is with a orange color and the symbol is in green color. So MD, NB, LR, Madam, Noble, Laure is your mnemonic. Atomic number 101, 102, 103. After that, Rutherford. Remember our rhyme? Rutherford dubbing, singing, बहुत हंस के करता है. हंस के करता है. बहुत as in बोहर, बोहरनियम. बहुत हंस के करता है. करता is nothing, but it is just a build up of the story of the mnemonic. मत देस as in don't give. What do not give? Rugged cones. Do not give rugged cones to the magician, which is Raftar. So why you have not written Raftar over there, sir? Because RF is actually Rutherfordium. So that's why I've written Rutherford also. So Raftar, dubbing, singing, बहुत हंस के करता है, मत देश, rugged cones. This will be giving you the symbol of the elements also. From what, sir? From atomic number 104, 105, 106, 107, 108, 109, 110, 111, and after that 112. Sir, what else, sir? I will be having more 6 elements. So after 112, Neha, what is the mnemonic for separately? Now this is a mnemonic which we have not done in the periodic table, because obviously they are all radioactive. The last element, the 7th period element of the P block family. So the 7th period member of boron family is NH. So what is the mnemonic to learn them? Obviously they'll go from atomic number 113, 114, 115, 116, 117, and 118. So what is the rhyme? Neha fly to Moscow. This is irony because my elder sister name is also Neha. So Neha fly to Moscow to live with who? To live with tennis OGs. Everybody, you Gen Zs nowadays, you are very much in love with the word OG. I do not know its full form, but yes, OG. So I mean, I have started my online journey. I have been teaching offline since 2012, but yes, post the beginning of my online journey just the previous year, I have seen this, the OG. So tennis OG. So Neha fly to Moscow to live with tennis OG. They constitute atomic number 113 to 118. Now, sir, coming back to the names. So atomic number 1 is Mendeleev. Beta, always try to iterate them, try to speak them aloud. Do not try to mug them up, just speak them aloud. Let your words reach your ears and it will be in your system subconsciously. So 101 is Mendeleevium, 102 is Nobelium, 103 is Laurentium, 104 is Rutherfordium, 105 is Dubnium, 106 is Seborgium. Say with me again, Seborgium. It is Seborgium. After that you have atomic number 107, which is remember this mat बहुत हंस के, बहुत as in BH. So it is borium, the after the name of the scientist. 108 is hasmium, HS, hasmat. Now mat is metnerium. This is metnerium. 110 is 110 is dumstadium. Now this is dumstadium. After that 111 is rontgenium. 1112 is obviously the cone CN. This is copernicium. Now after that, sir, the P block elements, that is even not we have not done in the periodic table also. So again giving them separately. So Neha fly to Moscow to live with tennis OGs, the tennis stars. So Neha has fly to Moscow to live with those tennis OGs. So now what is the name, sir? Atomic number 113, that is for Neha, symbol NH. So it is Nehonium. Neha, Nehonium works. 114 is Flerovium. It is Flerovium. 115 is, it is Moscow, so it is Moscovium. And 116 is Livermorium. It is Livermorium. 117 is again the word tennis, so it will be helping you because its name is also tennisine. It is tennisine. And 118 is the OG, which is nothing but oganesson. This is oganesson. So I hope I am not asking you to learn the names also, but at least learn the mnemonics, know their symbol, so that if at all required in your examination, you can land with the element identification. Now, why I'm saying this is, beta, because these questions have find application. So let us do the answer also I have given over here. but let me hide that answer and give you 45 seconds to at least give me an answer for this. So the first poll for the day, try to answer this. Try to answer this, because these were the slides and I'm trying to hide the slide. I'm trying to hide the answer. So just make it a shot. Yes, Pihu, perfect. Pihu is writing the names, beta. That is obviously one way of learning. So good, beta. Appreciate your efforts. Let me pour some coffee for myself. Chalo, perfect, guys. Perfect. Three. Okay. Acha, Pihu is now saying B. Okay. I guess this is quite doable, beta. Because we have recently done this. Obviously, A, which is group 15, also known as nitrogens, the nitrogen family. So the last element of nitrogen family, Neha, boron family, fly to Moscow. So third finger, Moscow as an MC. So obviously this will be, obviously this A will be 4. So A will be 4. So I am left with option 3 gone, option 4 gone. Either 1 is correct or 2 is correct. Now, chalcogen. Chalcogen, remember that rhyme. Chalcogen is salt producing. So it's a Latin name for salt producing. That is chalcogen. That means salt producing, that means chalcogen. So who are these elements who are salt producing? Sir, oxygen family. So oxygen family is also termed as chalcogens. Therefore the fourth finger, so Neha fly to Moscow to live as an LV. So this B is third. Sir, B is third. That means you definitely have your answer. Then halogen is obviously TS, tennis, TS, tennis, OGs, that means noble gas is OG, so noble gas D is 4. So definitely your answer is 2. Let me see, because this is the thing that we have done recently. Chalo, perfect, beta. Good participation. Moving to the next one, beta. Chalo. Moving to the next one. Now, we'll be coming to questions only, beta, but after a few minutes, let us discuss the conceptual theory also for 15 minutes, and then definitely we'll be seeing the application of those concepts that we have learned in the complete inorganic area, and then we'll be doing questions only. Now, position, that means, sir, now you are talking of the block elements. So why a d block element is called a d block element? Because last electron is going in d subshell. What will be an f block element? Where the last electron entering into an f subshell. All the D and F block element are termed as transition or inner transition. No, I already told you this, that those who are having properties because of the participation of D subshell. So zinc, cadmium, mercury, because of not participating, they are not considered as transition. What will be S block element? Where last electron will be entering the S subshell. What will be P block element? Where last elements entering on the P subshell. What will be D? Sir, you have already told us. Now, what are the number of periods that you have in your periodic table? Sir, 7th period. What is the trend of quantum theory that we have just finished together? So first will be 1s2, hydrogen and helium. Then it will be 2s2 and 2p6. Then it will be 3s2 and 3p6. So 3 periods done. After 4th period, the filling of D will start. So this will be 4s2. Then I'll be having 3d10, and then I'll be having 4p6. So make sure you're marking this, beta, that whatever is the period number, the principal quantum number for S and P remains the same. The principal quantum number for D is 1 less. Similarly, this will be 5s2. After that, 1 less, so 4d10, and this will be 5p6. This will be 5p6. After that, sir, 6s2. Just one this is obviously ulanghan. This is obviously the non-following disobedience of Aufbau, that one element, one electron, which one? The lanthanum. That is 5d1 is filled first. So after that 5d1, let me write it with different color. First we fill that 5d1, then we fill all the 4f14, then we fill the remainder of 5d2 to 10. This is just the disobedience of Aufbau rule, which modern periodic table is doing. Rest everything is same. Now the remaining is, sir, because period number is 6, so it will be 6p6. Post that I'll be having over here what beta? Sir, 7s2. Then sir, just 1, so 6d1, and after this 6d1 I'll be filling 4f14, and post this I'll be filling 6d2 to 10. After that, sir, here again 7p6. So this constitute what? So this constitute your 18 groups having 118 elements. So what will be the position of 119th element, sir? Again S block, although it is not discovered. If you go into your scientific journey and maybe you find another 119th element or 120th element, so what will be its place? So now it will be just following the periodic table is ready, the concept is ready. Now we just have to find it in the mother nature, and it will be coming, it will be called 119 will be called as a alkali metal, 120th will be called as an alkaline earth metal. Chalo. Moving forward, sir, this lanthanoids and actinoids I've already told you. So moving forward to the electronic configuration. So sir, electronic configuration also we have done. So let us do the generalization, because this generalization is also very much loved by NTA. So for S block element, sir, you just have to fill NS 1 to 2. What is N? The period number. For P block element, sir, NS2 will definitely be filled and period number remains the same. So NP126, that is boron family till inert gases. What about D block? Sir, D block will be, sir, NS, but remember the chromium and copper thing. But actually, if you take palladium, then sometimes 2 electron can jump inside. So it can be 0, it can obviously be 2. Then sir, N-1, because 1 less than period number, and D are filled from 1 to 10. But yes, if you just keep palladium separately, again a very important point, only palladium is the D block element which make use of the 2 valence electron of NS coming into the D subshell, the inner D subshell, to make it completely filled, to make it a stable electronic configuration. So if you separate palladium, then what will be the general electronic configuration for D block elements? Sir, in that case it will be NS 1 to 2 and N-1 D 1 to 10, because this 0 I'm considering only for palladium. So if palladium is excluded, a very probable logic beta, if palladium is excluded, then the general configuration is NS 1 to 2 only, because then everybody just all the exceptional elements disobeying Aufbau only has transaction of 1 electrons from valence NS to penultimate N-1 D. Just 1. Because of palladium, we are writing 0 to 2. So if somebody is writing palladium separately, make sure you remember this, that the general electronic configuration for D block elements is this. Moving forward, sir, what about F block elements? Sir, we have already seen the structure, so it will be NS2. After that, sir, just 1 is filled, which is N-1 D. Yes, sometimes because of half filled configuration of F also, those 7 electrons, and fully filled configuration, this 1 also can become 0. So it will be 0 to 1 and then N-2 F 1 to 14. I hope everybody is in sync with the atomic structure and with the structuring of this periodic table. Chalo. Also, beta. Yes, yes, Pihu, it was J PYQ also 119. So although the theory, the concept we are discussing with a very nominal pace beta, but they may be making 2 questions. Whatever theory I have taught you, they may be making separately 2 questions, and definitely it will be helping you to structure the coming inorganic in my today's session only. So again, a very important point. Chalo beta. What's not fair? So PU is also beta. IUPAC naming we already know that if an element is having atomic number more than 100, so just name the digit 1, 2, 3, 4, 5, 9 and suffix it with IUR. We'll be doing questions for that. Chalo, that everybody knows. So I'll be discussing question. I'm not leaving anything, but yes, just making things precise that whatever is most important should be discussed first. है ना? Chalo. Then this is a problem for many of the students. Sir, what are the exceptions of d block elements? In chromium and copper only we have that half filled or fully filled configuration thing. No, the one electron shifting is happening for many of the d block elements. So they are very important. So in how many, a question to you, in how many d block elements the ns electron makes a transition inside? Obviously one electron will make a transition because only palladium is an exception where both the ns electrons goes inside to the n-1th shell. So what are the exceptions? Giving you rhyme for that also. नवाबी NB, नवाबी क्यों करें? नवाबी NB क्यों करें मौत तक? That rhyme is still the same now. नवाबी क्यों करे मौत तक रुकावट राह में? Sir, why there is a gap? Because for all of them, how many electrons you will shift? Just one. Like for example, copper will be 4s1 3d10. Chromium will be 4s1 3d5. So because of stability of half filled and fully filled, how many valence electrons we make transition to the penultimate shell? Just one, not two. But yes, only for palladium, only for palladium, nickel PDPT. So nickel is 4s2 3d. So instead of 4s it will be 5s, instead of 3d it will be 4d. Nickel is 4s2, but both the two electrons will be gone from the valence shell, so this will become 0 and this 4d8 will become 4d10. So the transition of two electrons taking place from valence shell to penultimate shell only takes place in palladium. Rest for all of them, why they are exceptional? Because only one electron, so they are exception as an ns1, n-1d, 5 or 10. So they may be having that transaction to have a half-filled configuration or a fully filled configuration, but that transaction will only allow the transition of one electron. So how many of them are exceptional? नवाबी क्यों करे मौत तक रुकावट राह में पड़ी है. And after that, sir, copper family is copper, silver, gold. So silver, gold will obviously be there. And apart from PD, you have PT also. But yes, this PT is definitely very, very exceptional because ultimately it will be following this. So it will be 6s1 and 5d9. Here you will see that it is not even fully filled. But why it is happening now? These are some mischievous thing from chemistry, that once you have registered the property of platinum, the amount of energy required to remove one electron and the amount of energy required to remove the other electron makes a suggestion that its electronic configuration in ground state should be ns1 n-1 d9. Although this d9 is no half filled or fully filled, but still this is a piece of thing that you have to digest as per the factual thing. So I hope these exceptions are done. I'm just giving you this start of the rhyme, which is नवाबी क्यों करें, नवाबी क्यों करें, नवाबी क्यों करें मौत तक रुकावट राह में पड़ी है. And after that पड़ी है, you do not do any rhyme. Just remember this, that platinum, nickel PDPT has an exception, and copper, the coinage metal, definitely have electronic configuration like copper. So copper, silver, gold. I hope everybody is clear with this. चलो, थैंक यू सर. उस दिन जब आप नीट के सुबह जो लेक्चर लिया था उसमें से बहुत सारे क्वेश्चन बना इनऑर्गेनिक में. थैंक यू सो मच सर. सो नारुतु बेटा, this is beta, thanks to you that even before going to the examination you have participated in the live. That means you have discussed, you have solved those questions and tried to listen to those questions. So all thanks to you. A teacher beta, we are nothing without you. What is our result? You are our result. We cannot do anything. It is all you. So just trust yourself because you have immense potential. Now I hope you people know your power beta. I have read, I mean, yes, this is not a platform for this, but cockroach, I hope you remember this. So yes, we are cockroaches. But once we cockroaches unite, beta, we can transform our lives. We can transform anything. What we need to do is we just have to trust on our capabilities, which are huge. Even we do not know how much capable we are. So Naruto, beta, just understand this, that if you have spent that time during the morning of NEET session, rather if you do it for the complete days till 21st, wonders you will do to yourself. Wonders. So thank you, beta. Chalo. For now, already I've told you that initially what are transition elements. So giving you the complete theory. Sir, why you are interested in transition? Because beta, I told you I'm coupling periodic table with the most important chapter, which is DNF. So that means you'll not be doing anything for P and S block. So I'll be making you revise that also. But sir, it is removed from NCERT. But beta, through chemical bonding, they can ask their questions and they will be asking their questions. So I have separate question sessions. We'll be just finishing this logic conceptual part in the first hour, and then we'll be practicing questions only. So don't worry, we'll be doing everything. Hai na? Chalo. Purohit, hello beta. Yes, Pihu Yadav is giving some fire emojis. So, beta, as a teacher, you know what? Inorganic is very difficult to be taught because you have to continuously have to speak all the time. So, I need those fire emojis to back me up all the time. Thank you. Chalo. Hydrated myself with a bit of coffee. Now, chalo. So what are S block elements? Sir, they are highly reactive. Why they are highly reactive? Because they have 1 or 2 electrons in their valence shell, which is very easy to be removed. So how they are going to chemically interact? Sir, they are going to give electrons. So they are highly electropositive. And as we move along the period, we find P block elements which are less reactive. Now, why I'm saying less reactive? Because I am thinking of their electropositive nature. So they are most electropositive, and in the electrochemical series also they find their application in the as an element which are highly ready to get oxidized. So the P block element, they are less reactive, as in they are less electropositive, but because they have closen themselves, they have brought themselves into proximity of inert configuration, so they will definitely try to gain electron. And that gaining of electron makes them electronegative, which is the non-metallic nature. And what hangs on in between, sir, D block element, so they are neither there nor here, so that properties are also making a transition. Sometimes they show property more of like a metal, sometimes they show more property like a non-metal, and therefore they are also termed as transition elements. But this was old theory, because the new theory deals with the quantum configuration, and as per quantum configuration, if your d electrons are participating, then only you will be termed as a transition element. Else you may be a d block element, but you can be termed as transition element only when you have participating d. And because zinc, cadmium, mercury has no participation from their d subshell side, therefore they are d block element, but they are not considered as transition elements. The reason I have already given you, because they have completely filled d configuration. Moving forward, again a basic question, beta. Silver atom has completely filled d, which is 4d10. Sir, copper, silver, gold. So silver will be what? Sir, silver will be just like copper. So copper, silver, gold, as in Ag will be 5s1 4d10, just like copper. In nature, what is the maximum famous oxidation state for silver? Ag plus. So here I have 5s0 and 4d10. But beta, very rarely, not very common, but very rarely you find Ag plus 2 compounds also. And because this also exists in nature, although not very in a large magnitude, it is very rare, but still ultimately it exists. And if at all Ag plus 2 will exist in nature, that means it will have an electronic configuration of 4d9. So copper copper also attains +2, that you know. Silver also attains, very rarely, but silver also attains +2, and that will make silver d subshell participating for electronic transactions, and hence silver is regarded as a transition element. It is not just a d block element, it is also a transition element. Moving forward now, the number of unpaired electrons in Fe+2 beta. So again a practice, so giving you 45 seconds for this. Kindly do this. Integer type question. I mean, yes, obviously the poll will not function because it is an integer type. Acha, I can give you integer type poll. Okay, stop poll. Show result. Now I want to give you a poll for integer type questions. So 30 seconds now, because 15 seconds we have already destroyed. So 15 seconds now. Come on, quick. Do the electronic configuration beta, quick. Let us learn everything. Do the electronic configuration quick. I have these all bottles beside me, so I can pour everything. Ha, yes, Pihu Yadav. Yash, okay, very good, guys. Chalo. Answer is definitely 5. So, yes. Chalo beta. Let us see why it is 5. Sir, actually you have asked. The number of unpaired electron in Fe+3. So what is Fe? Let us revise, because these are very famous questions, sir. 4s2, then 3d6. Why? Because Shakti Walker Man Fe. Fe as in the 6th finger. So this is 3d6. But we are supposed to have electronic configuration of the ferric ion. So although 4s is filled first and 3d is filled later as per Aufbau rule, but what electrons you remove? Sir, the valence electron. So first you remove the valence subshell, which is 4s, the 2 gone. So this 3d6 will turn into 3d5, because after 2 I need 1 more. So this will be 3d5. So it will be having 5 unpaired electrons. 1, 2, 3, 4, 5. So number of unpaired electrons will definitely be 5. I hope everybody is clear with this. Moving to the next question. Try this one, beta. Again, not giving you. Chalo, okay. Okay, fine. ABCD. So 30 seconds for this as well. I thought not to give you poll for this, but okay. Let's do it. Let's do work on the polls. It will help you practice. Okay, Maxwell perfect, Yash perfect, Pihu perfect. Pathak ji is back, so Pathak ji perfect. Robin perfect. Nahi yaar, Robin is not answering. Robin is socializing. 4. Pihu is saying 4. Yes, Radha Yadav ji is also started working. So B. Chalo beta. Obviously answer is Bombay, because we have recently done this. Answer is Bombay. So Robin, Harish, perfect. Now the question says that you have to tell why it is not working. Now it is the set that contains atomic number of only transition elements. Sir, transition element, that is after if you just take 3D series. So sir, after calcium I have 21, so scandium, so 25, 21, 25 is obviously because 30. Now after that you should know the magic numbers. What is magic number? What is first period is having 2 elements, then second period 8, then 8, then 18, then 18, then 36, and then 36. So 42 will be what? Sir, this is last element is 10, third period last element is 18, 18 is 36, 36 plus 18 is 54. So that means, sir, it will be obviously 42 is just before 54, because from 36 to 54. So sir, minus 6 will be bringing us at 48. So 42 will definitely be a D block. So this is also correct. Now what about 72? Sir, 54 plus 86. 54 plus 86. 6 and 4. 36, 46, 56. 54. This is 0. Then 1. Then this is 80. Huh? Am I doing something wrong? What? 18 is 36, 56, 54. Acha, 32 yaar. I am sorry. I am sorry. This is 32 na. Arey, after 18 you add 42. So this is 32. I am sorry. This is 32. So this is 86, and 86 is obviously 118. So last element is 118. So because this is 72, so it will be between 86 and 54. And because this is 6th period, so here D will all apart from D, F will also be filled. So this 72 will also transform into a D block element. Because why, sir? 72, because actinium, the lanthanum after 54 is 57. After 57, from 58 till 71 was lanthanoids. So 72 will be the next element next to lanthanum. So la hafta, it will be hafnium. So yes, 72 will also be a D block element. A good question, but yes, if you have absorb that periodic table beta, you will definitely find such questions in your examination. So moving forward, chalo, perfect beta, perfect. Again, next question, the coinage metal, the electron present in penultimate shell. Just attempt this beta, not giving you a poll for this one. Just attempt this. Now, sir, what is penultimate? I have already told you that ultimately we have the valence shell is called the outermost shell is called the valence shell. Just next to the valence shell, you have the penultimate shell. If it is your nth shell, which is termed as the valence shell, then penultimate shell is definitely the n-1th shell. Again, for your understanding, you should know this again, because most of the students do not remember this. What is the next shell after penultimate shell? Sir, it is known as ultimate shell. It is known as, somebody says it ultimate, somebody says is anti-penultimate. So what is actually anti-penultimate? Sir, it is n-2th shell. Although in this question you are just asked about the penultimate shell for coinage metal. So sir, just think of copper. So copper is a coinage metal, valence shell is 4s. Let us make it ns. So after the penultimate will be third shell. So sir, 3d10. 3d10, then obviously because D is filled, so 3p will also have 6, and definitely 3s will also have 2. So 2 plus 6 plus 10, that means 18 elements. I hope everybody is clear. Perfect, perfect, perfect. Moving to, chalo, attempt this one beta. Quite a logical question. So giving you 45 seconds for this. 3, 2, 1, shoot. Please read the question properly. Please read the question properly, everybody. Because these are the topics we have just now discussed. So please read the question very properly. A. Okay. Pihu Yadav is saying A. Yash is also saying A. Robin is also saying A. Chalo. Let's see. Mn plus 2 compounds are more stable. Now, why these compounds are more stable? Because obviously manganese is 4s2 3d5. I hope now, because we have done so much for electronic configuration, so we know this. Okay, now Mn plus 2 will be what, sir? Mn plus 2 will be, sir, 4s gone, so it will be 3d5. And obviously this 3d5 will have stable half filled configuration. Now why it is stable? Because because of symmetry also, and because of the possible number of exchanges also. So remember, NCERT gave this exchange energy logic also. That exchange energy means as the number of degenerate unpaired electrons you have, the more exchanges those electrons can do, and the doing those exchanges will release energy. Once that energy is released, beta, energy is released from a system, and the energy of the system decreases. That means, sir, energy decrease, so potential energy decrease, therefore stability increases, because thermodynamically speaking, energy and stability are inversely related. So less be my energy, more will be my stability. So what about, sir, Fe plus 2 compound? This Fe is 4s2 6d 3d6, and 4s gone, so this will be 3d6. So it is not having any sort of stability in the gaseous form, and because this is more stable, so definitely D5 configuration is more stable than D6. So A becomes your perfect answer. So your answer is option A. Good person, 100%. Very good, beta. Moving to the next one. Chalo, try this one, beta. Although I'm not given, because sir, we have done the complete periodic table. So platinum, nickel, PDPT, nickel, PDPT. So PD has NS0, N minus 1 D10. This guy has exceptionally indifferent, although that thing I've already explained, that this will be uh, nickel PDPT. So sixth period, so it will be 6s2, but all the 2 electrons will be going where, sir? It will be going in the D penultimate shell. So this will be 5d9, because this will be 1, because that 0 only happens for palladium. And sir, because this is 6th period, so F will also be filled, so it will be having 4f14. So your answer for this question will definitely be option 1, 6s1, 4f14, 5d9. We have already done this, but very important, beta. These are all very famous questions. They have came in the examination also, and they have high probability of coming also this time. So attempt the next one, beta. Giving you 30 seconds for this. Quick. 3, 2, 1, go. Quick. 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 P who is saying 2. Choose the correct option having all elements with D10 configuration. Copper definitely correct. Zinc definitely correct. Then zinc, cadmium, mercury, they have just electronic configuration of zinc, which is stable, completely filled D. Then copper, silver, and gold, obviously they also have. Yes, very rarely you find Ag in +2 state. So therefore, if you explore all the options, definitely option 2 will be your right answer. So I guess we have spent sufficient time in this, so that I'm having this 100% also. So definitely answer is 2. Moving forward, attempt this one, beta. 30 seconds again. If you find any problem, please tell me, because I feel I have discussed. The only reason I'm showing you these questions is because, beta, they are periodic table also, they are D block also, and hence they are atomic structure also, because ultimately you can do all those electronic configuration once you are comfortable with the electronic configuration only. So hugely important questions to practice, and to have that confidence also that you know something. Yes, most of them are JEE mains question only, beta, because with these I'm trying to on Sunday we'll definitely having your NEET PYQs, but now here I'm more taking more of JEE mains question. Chalo, perfect. People are answering. Answer is definitely Bombay. Yes, perfect, perfect. So chromium, sir, 4s1, 3d5, so 4s1 gone, so this will be 3d4. That means sir, A is definitely 3. That means sir, A is definitely 3. So A is 3, so this is your option, and only once you solve A, this is what J mains is doing, beta. NTA is the whole soul organization, is a, yes, not at all trustable, but still ultimately they are setting your paper, and the number of papers they give in JEE mains are more in number. So definitely practicing JEE mains question gives you the actual idea that what is the area where they find interest in. So I hope everybody has done this also. Again, a JEE mains question, beta, the total number of ions. So please invest 30 seconds in this too. Yes, not giving you this. Why? Because sir, it is integer type. So again, starting the poll for you with an integer type thing, but giving you 30 seconds. Shoot. Integer type question, beta. Integer type question. Quick. Quick. The total number of ions from the following with noble gas configuration. So I need to have a noble gas configuration. Sir, you do not have to explore all the options. You know why? Sir, because SR, strontium, strontium, sir, alkaline earth metal. Cesium, alkali metal. Sr plus 2, so inert gas. Cesium, because now we know the symbol of the elements. Sir, lanthanum, that 2 plus 2, sir, it's valid. It will never, sir, lanthanum is filled ultimately from 3 electrons. So plus 2 will still have 1 electron in the valence shell. And because not valence shell, yes, it will be 6s2 and that's 5d1. So but still, the in order to have inert electronic configuration, it has to lose one more. So that 5d electron also has to be lost, and because of that, this will not have inert configuration. Sir, Pb is a p block element. That p block element losing 2 electron will not make inert configuration, because it has to lose so much lot of d also and s also. So definitely they will have pseudo inert configuration. They may have stable electronic configuration because it has a strong Z effective, but sir, they can never achieve exact inert configuration. So definitely not an option for us. Similarly for ferrous ion also, and similarly for YB. Sir, YB is the lanthanoids. सीना पार नदियां पीएम की समाई यूं गदगद तब दिलिए हुआ है तुम वाईबी लूट लो तो ये टर्बियम सर दिस इज एंड ऑफ एप्लॉक. सो they will never attain inert electronic configuration. So only two of them, which is strontium and cesium, has exact inert configuration. So answer for your question is 2. Good participation, and I hope after that periodic table that we have seen, it is quite doable for everybody. है ना? Chalo, moving forward. Now, important point, beta. Now, important point. What is that important point I'm talking right now? Chalo. What is that important point that I'm talking right now? Okay, you are in hospital. Okay. Chalo. Don't worry. Chalo. What is that important point we are talking right now? Sir, melting point. Especially this, I'm talking for D block elements. Now, sir, what is melt? Beta, what state of matter we melt? Sir, we melt a solid. Once you melt a solid, what takes part in the interspecies attraction? Sir, the intermolecular or interspecies attraction in case of these D block metals are the metallic bonding. What are metallic bonds? In general, you can think of that metallic bond just like a covalent bond. Whenever I am a metal and I'm existing in nature, what valence electrons, the unpaired electrons, the unpaired valence electrons that I'll be having will be able to interact with the unpaired electrons of the another metal of my same kind. So that interaction is termed as metallic bonding. Because the D block elements the energy difference between ns and n minus 1 d subshell is so less that both ns and n minus 1 d subshell electrons are termed as valence electrons. So they have more number of participation from the electron side, and hence more be the number of unpaired electrons in the valence shell. The so-called valence shell is n minus 1 d also, although it is penalty made, but because the orbitals are so large and diffused, that's why both ns and n minus 1 d electrons are considered as valence electrons, and because they are considered as valence, so they'll participate. They'll participate in metallic bonding also. What is metallic bonding? The number of unpaired electrons present in these so-called valence shells. So more be the number of unpaired electrons, more will be my metallic bonding. More and stronger will be my metallic bonding. Stronger temperature I will be requiring to break that bond, and hence more will be my melting point. So this depends upon the strength of metallic bond, and definitely, as I've already told you, this depends on number of unpaired electrons and the number of effective and the actual effective nuclear charge, because d block elements have strong the nucleus has so much of electrons, the nucleus has so much of protons, I beg your pardon, and the D and F subshell has got poor shielding also, so their Z effective is quite large, because as Z increases, Z effective increases, and because the shielding is very poor, so the increase in Z effective is quite large. Now, specifically talking about the 3D series, because 3D series NTA loves. Now, as you move along the period, that is from scandium, sir, in scandium, I have only one unpaired electrons. So metallic bond the tendency to form metallic bond will be less. Although the s electron can also get excited, but in general, we see the number of unpaired electrons. So number of unpaired electrons is 1. Titanium, it is increasing to 2. Vanadium, it is increasing to 3. Chromium, sir, it has increased to 6. That's why metallic bond starts increasing, and therefore melting point also starts increasing. After that, sir, the pairing of electrons will take place, because here, how many unpaired electrons you have? 5. Here, 4. So see, the number of unpaired electrons have increased, and now it has started decreasing. So this is the periodicity. There is no general trend of periodicity in D block elements, and that's why NT also find very much interest in this. So gradually number of unpaired electrons increases, so melting point, hardness, the enthalpy of atomization, all of these factors increases in the middle, and post that it again starts decreasing, because you very well see the number of unpaired electrons are getting decreased, reaching to yes, 1 over here, but ultimately in zinc number of unpaired electrons becomes 0. So the extent to do metallic bonding also decreases. Now, sir, the very famous graph for melting point, yes beta, very important. So if you see this NCERT graph for melting point with atomic number, then for 3D series it looks like this. Like for example, I've already told you, first is it increases and then it decreases. But yes, because it's an NCERT fact, so beta, it increases till chromium, and then it decreases. But in that decrement also there is very beautiful story of manganese, because chromium, Shakti Walker, Man Fe. Sir, manganese also has quite number of unpaired electrons, in fact 5. Then why there is a dip? Because beta, manganese has a stable electronic configuration, and whenever a species is stable in itself, it will not try to interact more, because more stability as in less reactivity of any sort, because ultimately those metallic bonds are what, just like the number of unpaired electrons making a covalent bond, but because they are responsible for the physical property, because melting is not a chemical change, it is a physical change, but that physical change is also decided by what? The number of unpaired electrons forming that metallic bond, which is nothing but attraction between unpaired electrons. And that metallic bond, because I'm having a stable electronic configuration, manganese, therefore you find a dip in the melting point. Similarly, If you talk of the Z effective, then you can understand with Z effective also that, sir, as you move along the period, then Z is increasing, so Z effective will increase. Sir, as inner shell electrons are filled, which are offered in poor shielding of D in this particular case. So, sir, Z effective will increase to a highest extent, and with increase of Z effective, the ability to do metallic bonding will also increase. Hence, you find an increment, and after that you find a decrement. Why? Because as soon as more number of D electrons start to participate, they start to provide more and more shielding. But sir, you said D shielding is poor. Yes, let's say you have you are strong enough and you have a fight with a 12-year-old kid, so you can obviously beat that 12-year-old kid. But if more and more 12-year-old kid start participating, then they can even beat you. Just like people in power are so strong, so powerful, but as the number of cockroaches will keep on increasing, they can overthrow any and everybody. So I hope that moral science, which is actually going around these days right now, so they can even dethrone, make the king disappear. And this is happening here also. This is the chemistry of life also, and here also. So that's why you find a dip. After that, sir, if you talk down the group, sir, then as you move down the group, the number of protons are also increasing. Therefore, the effective nuclear charge in general increases. Moreover, after as you move down the group, sir, F orbitals are also filled, and F electrons provide worst shielding. D has poor, F has worst shielding, so Z effective increase to the maximum extent. So whose Z effective will be largest? Sir, 5D. And because of this, once you plot the graph down the group, you will find an increment in melting point. That means the element just beneath a corresponding 4D series element, 3D series element, 4D will have a higher Z effective, therefore a stronger extent to do metallic bonding. 5D will have even higher. Why? Because this will also have shielding of protons. Protons also extra 14 protons because of first time filling of 4F. And the shielding of F is also poor. So because of the trend of this Z effective, what is the graph that you see? These are the melting point of this is 3D series. This is 4D series. You can see melting point is higher, and definitely for 5D it is much higher, because here the F is also playing into is also having its play, which has increased Z minus sigma, as in which has increased Z effective to the largest extent. Yes, there is an anomaly because it's an NCERT fact beta that it decreases, but how to compare on an exact manner, exact fashion, because it's an NCERT fact, so telling you this also. If you compare copper, silver and gold, then who has a higher melting point? Beta, copper has higher melting point, gold is having an intermediate value, and silver has the least melting point among coinage metals. A very famous NCERT fact beta. Please remember this. This is the exact trend for their melting point. Moving forward, do we have some more anomalous behavior? Yes, sir, because they also have stable D configuration. Zinc, cadmium, mercury, which are not even regarded as transition elements, they also have a very anomalous behavior if you talk of their melting point. Sir, we are expecting 5D should be having the highest, but you also know this, that at room temperature mercury is a liquid. So that means mercury is a liquid, sir. That means its melting point is very less. Yes. So what is the anomaly? In general, this is my fashion, that as you move down the group, Z effective increases. So melting point, the capability to do metallic bond also increase. But yes, for species having stable D configuration, copper, coinage metals, and zinc, cadmium, mercury, zinc has highest, then cadmium, then mercury. So here 3D element has won the battle in the zinc in the group 12 elements. After that 4D, and least is 5D. But here obviously 3D is again here also the winner, but here 5D is the winner and here 4D is the winner. I hope you should remember these anomalies. I have not discussed much of exceptions beta, but there are some very famous exceptions which are a very probable topic, which are very probable questions for your RE-NEET examination, because they are nothing but NCERT. Again, for melting point, I've already told you that the high melting point of metal are attributed to the involvement of greater number of electrons from n-1 in addition to ns, because ns and n-1d both behaves as valence shell, and more be the metallic bonding, more will be your melting point. So in any row, the melting point first rise to a maximum because unpaired electrons are increasing. But yes, there is anomaly also, where you have found anomalies are manganese also, and in 4D series also you have found that anomaly, that dip. Yes, in 5D we had no such anomalies. Just remember that graph also, because they are actually your JEE mains and NEET questions. Chalo, moving forward. What about enthalpy of atomization? What is enthalpy of atomization? Sir, if I have a solid metal and if I give this metal some heat, then this will turn into a gaseous metal. So this is also called enthalpy of sublimation. Yes, some people can also call it thermodynamically enthalpy of sublimation. But technically, this is also called enthalpy of atomization. Then it will depend on what? Sir, it will again depend on upon the melting point, upon the extent to do metallic bond. So that trend also remains the same, that along the period it should increase till the middle. After that it will decrease, and down the group it should also increase because Z effective is increasing. So the reason also I've given you, and this very important graph beta you should also know. Then sir, if it is just the same, then why you are telling us? Because again it has also got some NCERT NCERT tadka. What is that tadka? Among 3D series, who has highest enthalpy of atomization? Not chromium, it is vanadium. Why? It is a basic property beta. So some physical properties you should learn because they are NCERT logic. So why I have specially brought this graph for you? Because most of the students have this, because obviously that is a concept. So they will think that's a chromium will be having highest, because melting point of chromium is obviously highest among 3D. But for enthalpy of atomization, vanadium wins beta, and obviously as you move along the period, the zinc will have the least value. But please make sure that you remember this: in 3D series element, vanadium has got maximum enthalpy of atomization. Moving forward. Now, sir, because we have already discussed everything, so let us summarize it quickly. As you move along the period, what about atomic size, sir? Sir, general periodicity, if you do not think of D block element, then general periodicity says down the group atomic size increases and along the period atomic size get decreased. Now, sir, why it happens? Because as atomic number increases and shielding gets poor, the Z effective increases to the maximum extent, and because Z effective increases, so whatever size it is, atomic size or ionic size, all the atomic and ionic sizes decreases along the this I'm talking of along the period. And what about down the group, sir? Sir, down the group, electrons are filled in the next shell, and inner shell electrons also act as a shield, and therefore atomic size increases to the maximum extent. So atomic increment down the group is large enough in magnitude, decrement along the period is partial. But still a very important. Now, coupling up with D block logic. So let us explore this for, this is general. Let us explore this for 3D series. Then for 3D series, what can you say? Sir, 3D series we know, Shakti, Walker, Man. Sir, along the period you are saying it should decrease, and it decreases also. Along the period you are saying it should decrease because the fact you have already given, so it decreases also. So that means scandium has highest size, after that it is decreasing. So here till manganese it is decreasing. But after that what happens? Iron cobalt and nickel has approximately same size. Why? Because as number of d electrons, which are inertial electrons, start increasing, then repulsive forces become dominant. Remember, they are very of very less power. The shielding is very less. But if they keep on adding, if the population, although it has got no power, if it keep on assembling themselves, if it keeps on democratizing themselves, then they can dethrone even the strongest. So that start happening at the level of iron, cobalt and nickel, and that's why their increase in atomic number is approximately compensated by the value of this sigma, because their sigma keep on dominating. I'm not saying they have become much dominant, but yes, they start applying the same amount of pressure force which the increase in atomic number is. So ultimately it is nullified. So Z effective remains almost constant, and therefore their size also remains almost constant. And post that they will win, and because they win, therefore Z effective falls and therefore size increases. So for whom size increases? So for copper and zinc, the size start increasing. The beautiful NCERT graph, please remember this. Along the period it is decreasing. Iron, cobalt and nickel has almost same size, and post that the size increase. This is for 3D. Now sir, what about 4D? Then 4D and 5D obviously has larger atomic and ionic size, but yes, size of 4D and 5D are approximately same. Why it is same? Because once you move from 4D to 5D, the first time F subshell is filled, and that makes the Z effective so large that the Z effective of 4D series elements and 5D series elements, that is the amount of attraction force that the nucleus is providing to the valence electron becomes almost equal. Although for 5D series the valence shell will be 6s, but those 6s electron are also getting so much attraction that they come very close. How much close? Similar to the size of 4D series element. This is your famous lanthanoid contraction. And because of this lanthanoid contraction, the size is almost the same, which you can see over here also. But because lanthanoid contraction is again a very famous and important point, again a definite question for your NEET examination. So giving you the theory in writing for that too, that the second, which is 4D and 5D transition series, almost have identical atomic size despite the increase in atomic number. Why? Because of poor shielding of f orbitals. This is nothing but lanthanoid contraction. What is its application? That size is approximately the same. Now because we have learned the periodic table, so you can do that mnemonics, and you can find the elements that what 5D and 6D elements, what 4D and 5D elements are of same magnitude, that you can learn through the positioning of in periodic table. Like zirconium and hafnium has approximately got same size. What is the reason? Reason is lanthanoid contraction. I hope everybody is good. Moving to the next one. Chalo. So what is the consequence? Now because these elements are of similar size, so that is a very famous application for F block, D block and F block elements also, that therefore they are used in formation of alloys, because their atomic and ionic sizes are approximately the same. And because they are approximately the same, therefore they find large application in formation of all those alloys. Because what are alloys? It's a mixture of more than one solid metals. That metals generally form alloy, and those alloys have got tremendous application in day-to-day life. So what elements have got the capacity to form alloys, which are having very much less difference in their atomic size, because any and everybody can replace each other. And the basic reason because of the same behind the same atomic size is the lanthanoid contraction. So I hope everybody is clear with this. Chalo, moving to the next J mains question. Again, not giving you much time for this because we have already discussed this. The element which shows only one oxidation state. Sir, you told that for lanthanoids, for D block elements, Ns and N-1D both behaves as valence shell. Then definitely they will have a capacity to show variable oxidation state because they have variety. They have number of orbitals which are dying to participate in a reaction because their number of the number of shell valence electrons have increased because they do not have Ns just as their valence shell. They are offering also N-1D electrons for taking part in a chemical reaction. Therefore, they should have variable oxidation state. But if you reach an inert configuration, then who can reach that inert configuration very quickly? Sir, just at the beginning. Who is just at the beginning and just at the end, because they like zinc, it will have stable D, and at the beginning they just release those 3 electrons like scandium and form the inert configuration. So can you find zinc over here? Zinc, no sir. Can you find scandium over here? Yes sir. So scandium will be your beautiful answer, and I hope most of you must have given. Yeah, perfect, good participation beta, good. Chalo, attempt this one, the transition element that has lowest enthalpy of atomization. So I want, yes, perfect, lowest enthalpy of atomization. So please beta, just read, give it a shot. Lowest enthalpy of atomization. Quick. D. Yes. Who has the highest beta? Who has the highest? Krishna Kumar. Yes, perfecto. D is our answer. We have already seen this 100% because we have already seen the graph, because sir, all the D are paired, so they will have no metal interaction, hence no strong metallic bond, and hence weakest enthalpy of atomization. So answer is definitely 4. Who is having the highest? Vanadium. Enthalpy of atomization is exceptionally highest for vanadium. Attempt this one beta. 30 seconds for this too. Attempt this one. 30 seconds for this too. Chalo, quick. Robin is saying D. Arrange the following element in increasing order of the number of unpaired electrons. So you have to give the order of unpaired electrons. I hope most of you have got the answer. I guess it is 4. Okay. Still 83%. Fair enough, beta. Chalo, let us check why it is 4. Now, we just have to do that electronic configuration again, beta. So scandium will have, sir, 4s2 3d1, so number of unpaired electrons is 1. Chromium is 4s1 3d5, so number of unpaired electrons is 6. Vanadium is Shakti Walker, Wa as in third finger, so 4s2 3d3, so it will be having 3 unpaired electrons. Titanium, Shakti Walker Man Shakti as in second, so this will be having 2 unpaired electrons. Manganese will be having 4s2 will be filled, so it will be having 5. So who is having maximum beta? Sir, chromium. That means B is having highest. So just if you just check the highest element, you will be getting your answer. So I hope it was quite doable. But beta, please make sure you are practicing things to the maximum efficiency, because ultimately these are your questions. These are your JEE Mains questions. NT is also going to ask it in your RE-NEET examination on 21st. The only thing is you have to be quick with the justification. So for that, that's why I've given you the complete theory initially, and then we'll be practicing. Then we are practicing questions around it. Chalo, moving forward. So keep your toes on high alert so that you start to practice more and more, answer quickly, so that you can save time also to invest in your other areas of physics, chemistry and biology, है ना? चलो, now just quickly putting an end to the conceptual side of the inorganic. Sir, what about density, especially for D block elements? Now density, sir. Density is mass by volume. Sir, in general, nucleus decides mass, and in general, mass always increases. So density for D block elements also, if you go to their nucleus along the period also, or down the group obviously, you can think of by keeping the mass, the nucleus in your mind, so density will increase. But along the period also, we only focus on the nucleus mass, and according to that we can obviously say as mass increases, densities should also increase. Down the group, as mass increases, density should also increase. But sir, down the group, radius also increase, and volume is 4/3 pi r cube for a sphere. But still, increment is mass, if you talk of density, becomes dominant, and therefore we say that the decrease in metallic radius coupled with increasing atomic mass result in general increase in the density of these elements. Thus, talking specifically about the 3D series element, because they are very famous, thus titanium to copper, there is a significant increase in density. Make sure you are reading this. Titanium to copper, it is not taking zinc. Why? Because in the size we have seen, the size of zinc is large enough. Because the radius is large, so 4/3 pi r cube becomes more dominant. And yes, zinc in fact has the least density. Along the period, density is increasing, but zinc, instead of having the highest, has the least density among 3D series element. Again, a very famous NCERT logic. I hope, again, this is a question also, so because I have just now explained you this. So sir, along the period it should increase, so chromium, iron, cobalt and copper, so it is increasing. And who should have the highest? Sir, zinc. Instead of highest, because of the incremental size, the 4/3 pi r cube factor becomes dominant, and it has got the least density among 3D series elements. So option 1 becomes your beautiful right answer. I hope everybody is clear with me. Moving forward, chalo, coming to the basic ionization energy beta. Now for this ionization energy, I've already written things for you, because this is periodicity. Now make it quick. Atomic size increases down the group, already told you. It decreases along the period, already know. Sir, down the group, increment is large enough, sir, because in atomic size is increasing to the maximum extent down the group, therefore distance between nucleus and valence electron is tremendously increasing. Therefore, amount of energy required to remove one electron will definitely decrease. So what is the general periodicity for atomic size? It should for ionization, it should decrease. It should decrease down the group, and it should increase along the period. Now this is the general periodicity for your periodic table. Talking specifically about D block elements. So we know down the group, you said period size increases, so ionization should decrease, so 3D should have highest, then 4D, agreed. But 5D, sir, F block start to fill. Once you talk of the 5D series element, sir, their Z effective is quite large, already discussed. So because of that, 5D series has strong Z effective and electron will be holded to a maximum extent. The electrons are holded to so much extent that even the size are equal. And once you try to remove an electron, because the nucleus is strong enough, so it will not allow the electrons to be leaving the atomic structure. Hence, 5D series elements have high ionization energy than 4D. Combining all of them, then down the group, what will you conclude generally? That 5D should have the highest ionization, then 4D, and least will be then 3D, and least will be 4D. I repeat, 5D should have the highest ionization, then 3D, and least will be 4D. This will be the general trend for D block element down the group. Sir, is this trend will make every question for ionization good questions also possible for us? Yes. Sir, are there some exceptions? Yes. Sir, then how will we learn them? Let me give you a mnemonic also for them. So exceptions, again a very important point from NCERT. People miss this. People don't read this. Let me give you a mnemonic. What is the general trend for ionization for D block down the group? For periodic table, we have already learned. Now for specifically for D block. Sir, ionization, highest is of 5D, then 3D, and least is of 4D. This is the general trend for this D block down the group periodicity. Now, whatever you are doing, you are including separate periodicity for D block. Is you are doing it. Why? Sir, because filling of DNF are taking place. If I talk of the first group, that is third group of 3D series of the D block, the first group of D block, overall third group, scandium and the remaining group, as in scandium, ytterbium, lanthanum and actinium, they have just got the NS2 filled. So they do not have any of those special D and F electrons and protons. Then why you will follow any of those periodicity here? No sir, we will not follow. So they are just normal elements of your periodic table. Yes. Are they arranged down the group? Yes. Down the group, what can you comment about ionization? Sir, size increases, so ionization should decrease. So for them also it decreases. So this is good. But why I am saying exception? Because for D block we have a general trend. What is that general trend? 5D should have highest, then 3D intermediate and 4D least. Because for D block we have generalized on a different fashion. So taking that general fashion as a reference, this becomes an exception, which is, if you talk of periodic table, is fair enough. I hope this exception is everybody in sync with. Now, do we have some more exception? Yes sir. What is the rhyme? You must have heard from your grandparents, sir, VCR. A cassette used to come, a black color cassette, and used to watch movies. So VCR. So not that VCR, learn VCN. VCN. Vanadium group, chromium group and nickel group. Rhyme is VCN. VCR and VCN. So VCN. Sir, what exception they have? Opposite. But a regular fashion. It should decrease. Here it is point blank increasing down the group. The ionization enthalpy is point blank increasing down the group. Yes, again it is a statistical, because it is an experimental data, but if you grab, if NTA is going to grab your neck, no, explain this, then whatever things you can explain, only the explanation only lies to the discussion that we have already done. For example, what was the general trend that you were expecting? This should have highest, then you should have intermediate, and you should have least. So if at all a question is thrown at you that why it is increasing, that means you are expecting palladium to be less than nickel, but here palladium is more than nickel. Why? Then for such questions you can do explanation also. How? Sir, we already know. What do you know? Sir, you told us this is 3D8 4s2. So, but this is 4D10 5s0. Remember? So Removing one electron will be from what subshell? Sir, from stable, fully filled. Removing one electron will be from what subshell? So this is partially filled configuration. That's why removing 4D electron which is having stable electronic configuration will be more difficult, and hence if you compare nickel and palladium, palladium has got higher first ionization enthalpy. Although the trend is you should have highest, then you should have 3D series, then you should have. But VCR what trend? That first ionization enthalpy increases down the group. You can give an explanation also, or else you should learn these things also. Moving to the, I hope everybody is clear. Chalo, perfect. So ionization enthalpy, sir, are there more conceptual questions regarding? Yes, beta. Sir, what is the logical explanation? Whatever we have done in the similar manner, because JEE Mains has also done this, loads of statement based questions, beta. So I have brought some statements for you so that we can generalize and summarize all things we have done till today, till this time, है ना? चलो. So if a question is, if a statement is thrown at you that chromium and copper have a high value of second ionization enthalpy based on extra stability of their half-filled and completely filled electronic configuration, how can you how is it statement true or false? Yes, sir, because chromium is 4s1, copper is 4s1, 3d5 and 3d10. So one electron they will be loving to lose, but removing second electron will be from stable half-filled and fully filled configuration. So this is definitely true. And because this is true, so you can correspondingly make your choices in the questions. Manganese and zinc have high value of third ion, same, sir, 4s2 gone, zinc 4s2 gone. So after +2 they will reach +3, but +3 the third electron has to remove from stable half filled and stable fully filled. Therefore this energy, the value of IE3 as in third ionization energy, will also be not high, it will also be very high. So those periodic table and electronic configuration explanation will help you to solve so many questions. Similarly, sir, talking of ionization enthalpy, let's say along the period titanium and vanadium, I'm throwing a question at you. Titanium and vanadium, I'm telling you, titanium has more ionization energy than vanadium. Why? Sir, first tell us the periodicity. Periodicity of what? Periodicity of the ionization energy. So first let me give you that periodicity. Sir, you have already told us along the period ionization energy should increase. So from scandium to titanium, increasing. Titanium to vanadium, it should increase, but there is a anomaly. Again increasing, and you find an anomaly in cobalt and nickel. Else the general periodicity is ionization energy is increasing. You have seen your NCERT also. NCERT also write this, that periodicity of transition element cannot be explained, but I'm explaining it to you. Why? Because this is how statement based questions are going to trap you. Like for example, first thing is you should remember this, that general trend is ionization energy should increase along the period. General trend. Where is the anomaly? In vanadium and in cobalt and nickel. Most of the time remembering this will make a question, will make a good question attemptable for you. So vanadium has got exception, cobalt and nickel has got exception. If a statement based question is thrown at you, that why, like for example, I'm throwing at you that along the period it should increase, but still titanium is having more. Why? Vanadium 4s2 3d3 electronic configuration. Okay. If you remove one electron from vanadium, how many number of exchanges it can do? So this can exchange with these two, so 2. Second, this one can exchange with only this, so how many exchanges possible? So 3. Once you remove one electron from vanadium, it will form vanadium plus cation. Electronic configuration 4s1 3d3. The 4s1 electron you can think of going to 3d. Why? Sir, because outermost shell can obviously come inside. So it becomes 4s0 3d4. So if it is 3d4, then how many exchanges possible? Sir, first can do exchange with 2 3 4, so 3 exchanges. Second can do exchange with 3 and 4, so 2 exchanges. Third can make exchange with 4, so 1 exchange. So how many total exchanges? 6. So if a system was capable of doing only 3 exchanges, now is doing 6 exchanges, so exchange energy will be released. Like for example, you are living in a township. Now you have, in a township, you have 4 buildings. Those duplex, 4 duplex are from your family only. So you can stay in this duplex for one day. In the next duplex, you can switch with your cousin. So that will give you more freedom. That will give you more entropy. Therefore, you can move here and there, and you will be so much happy inside your township that you will not be interacting with outside world. So what does that mean? As an electron, you are happy enough to get delocalized within your degenerate orbitals, and you are not participating outside. That means by you are stable. You are not participating, you are not reacting with people. That means you are stable. That is the meaning of exchange energy. More energy you release within your township, within your ghar, within your home, you will not be needing any friends from outside. I am very much happy within my home. I do not have time to play with anybody else, to talk to anybody else. We have so much of extended family that we are happy within ourselves. I hope you are understanding the meaning of exchange energy, because I know 90% of the students do not understand this. So I hope I have tried to give you a common sense, a chemistry, actual chemistry behind it. Chalo. So, sir, from vanadium, once vanadium has just given one electron and formed vanadium, sir, number of exchanges are so much increased. So you tell me, will vanadium be interested in going to +1 state? Yes, sir. Because it is very much happy to have those high number of exchanges which can release more energy and can stabilize itself. That means the amount of exchange energy released will be compensating. Let's say if you require 200 joule of energy, sir, 150 joules, so it is creating within itself. You just have to give 50 rupees, it will itself give 150 rupees to you. Nahi, ionize me. That's why the ionization energy of vanadium is less, although from periodicity you were expecting it to be more. So this is how you will conceptualize certain conceptual facts like exchange energy in explanation of some statement-based questions. Now, this is a simple statement-based question that in fact +3 oxidation state of copper and zinc is not even possible, because copper and zinc both, after attaining +3, +3 is not shown by copper, and for zinc it is very high. Why? Sir, because they have 3D10 configuration. So if you try to destabilize that fully filled configuration, they will not entertain it. Hence, for them to attain +3 oxidation state is not even possible, because nobody is going to provide them so much of energy, because ultimately I will take that electron from another species. So that's why their +3 oxidation state is non-existent. So again, a statement based questions. I hope everybody is clear. Now I am done with the discussion of theory beta, although I'll be giving you these notes, so let me keep them. Now let us directly jump to questions beta. Now let us discuss only questions, because yes, I'll be discussing theory also, but most of the theory we have done. So I hope most of you will be watching this in a recorded version, because I don't see much of crowd participating over here, but still, all those who are here, at least you are getting things completely in sync to yourself. If you have any doubt, please post that doubt in the comment section, and let us now do the application of the inorganic that we have read. And definitely we'll be doing the theory also, but now we'll be doing questions and learning theory along with it, because periodicity and the block chemistry we have more or less completed. So let us directly jump into questions now. So the first question to you, I'll not be giving you more than 30 seconds for each questions, so quick beta. Let us do participation now. Let us participate together so that we can enhance and maximize our revision for the ultimate day of 21st of June. Anna? Or else we can do one thing, pata hai? The theory part we have done na. Now we are going to discuss theory but with questions. So beta, pi lens pole you can install. So what we can do is, uh, let us do this question and let us take a 10 minutes break, because my coffee is done. Let me fill my coffee again. Anna. So we'll be taking a 10 minutes break after this question and then we'll be coming back. Chalo. So I hope you have attempted this. Okay, I guess the poll is happening at your end or what? Chalo, I've got no responses. So okay, I'm getting response in the comment section. Chalo, let us attempt this beta. The element that does not belong to same period of the remaining elements, modern periodic table, who do not belong to the same period. Sir, platinum, sir, it's a sixth period element. How? Nickel PDPT. So sixth period. Osmium, sir, osmium. La hafta varnare usdhar irdhar. Osmium, sir, sixth period element. Sir, PD, nickel PDPT. Sir, it is fifth period element. Iridium, la hafta varna usdhar irdhar. Sir, it is also six periods. Obviously, third is your right answer. Obviously, third is your right answer. So yes, we'll be doing such questions to practice that whatever we have studied. But let me just take this privilege of filling my coffee again. So we'll be meeting back at, this is 2:19 na? We'll be meeting at 2:30 beta. So just 10 minutes break. है ना? Let me fill my coffee cup. We'll be meeting at 2:30. So 2:30, 10 minutes break. You also get your stuff together and we'll start again. Chalo. Welcome back. Welcome back. Welcome back. Chalo. I hope I am live. I hope I am audible and visible, everybody, because I guess I just switched off streaming for a second and then I have removed that cover. So just give me a confirmation, beta. Chalo. So Henry, I'm audible and visible. Perfect. Shall we proceed? Guys? Yeah, Henry has given welcome back. Chalo, chalo. Hema, Yash. Chalo, beta. Chalo. Let's start. So now from this question onwards, we'll be discussing the relevant questions, and definitely, if required, we'll be discussing theory also. Why I'm saying if required, because most of the theory for block chemistry and periodicity related periodicity related conceptual thing we have already done. So yes, now I can see those fire emojis also, so that definitely motivates a teacher, beta. Thank you. So let's start. Chalo. Now again a J mains question. Acha, this one we have already done, na? Ha. The nitrogens, this one we have already done. So moving to the next one. This one we have already finished. Chalo. So 30 seconds for this one. I have already told you that we have a very traditional question, that is, if an element is having atomic number more than 100, then as per IUPAC, you can give its name using the number names and suffix it with a EM thing that will give you the name of the element. Like for example, the IUPAC name of an element with atomic number 119. We have already done this. This will be an alkali metal, although 118 is existent as per now, because 119 is not discovered. But if at all you have 119, what will be its name as per IUPAC? So 1 as in un, again 1 as in un, 9, the word is n, and suffix it with the word IUMEM. So this is definitely option B is your right answer. Let us decode the other also so that we can learn. So this is 1 octium as in 8. This is 1 nil ennium as in 9. This is 1 eum as in 111. So our answer is definitely Bombay. Chalo, 85%, fair enough. Moving to the next one. Again, the name identification, beta. So there, this is a 2020 question from JEE Mains. It has asked you the element number also, and you have to relate it with the name of the actual compound. So that's why we have done the revision for such questions also. So the theory has been revised. Can you give me the answer? Quick. 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 To get 170 marks in chemistry, sir, NCERT questions and exemplar with NEET PYQs and JEE. More than sufficient. Sonam, if you are including JEE mains PYQs, it is more than sufficient. But yes, do not mug the answers. Learn the concepts. Chalo, I hope you have got answer to this one too. I guess the time has also ended. Answer is definitely C. Still 80%, beta. I mean, yes, sir. This is 110, which is Mendelevium. How we know this? The rhyme. The rhyme starts for 101 is what? Sir, 101 is Mendeleev, Nobel, Laure. So 1, achas, this is 1 nil. I'm sorry. This is 1 nil. So 101. 101 is Mendeleev, Nobel, Laure. So Mendelevium, this is correct. 10 as in 3. So Mendeleev Nobel Laureate as in Laurentium. So this is also correct. 1 nil Hexium as in 6. So after Mendeley's Nobel Laureate, what rhyme we have, sir? After that, you should think of the the D block elements. So post actinium, what we have, sir? Acha Raftar will be 104. Raftar dubbing singing. That is SG. So SG is Seborgium. So this is obviously correct. And obviously D becomes your right answer. I hope we have done quite a lot of that practice. So 80% of the students have got this right as well. So good one. Chalo. Next question, beta. The element with atomic number 110, again not yet discovered. So what it will be, sir? That also we know. 118, so 19 will be alkali, so 20 will be alkaline earth metal. So this is simply 3. Moving to the next one. Yeah, so because a statement based questions, beta, and please expect such questions in your examination, because these questions check your language also and your preparation also. So please make sure you read the statement properly and give an answer quick. Please read the statement properly. It is saying which is not true. Most of the students do not see this not. So this not is not important. It is actually a trap which will make you a -1 mark. So make sure you are reading things properly. The question says the property of element are function of atomic weight. Incorrect, because incorrect, so it will be an answer. So I need A. They are not giving me A. The properties of this is correct, therefore not an answer for me. So B is definitely gone. Elements having similar outer electronic configuration are arranged in same group. It is saying period. It should be group. Because it is saying period, so it is incorrect. So C is definitely an answer. That means option 4 is your right answer. So but we can obviously try to read all the questions, but option elimination works most of the time, and I guess this has worked here also. So option D is your right answer. 70%, fair enough, but I'm expecting more out of you. You should also expect more. Now, the element Z having atomic number has been discovered recently. If it will belong to which of the family and electronic configuration? So 114, 118 is inert gas. So 17 will be 17 will be halogen, 16 will be oxygen family, 15 will be nitrogen family, and this will be carbon family. So carbon family as an option 3 will be your right answer. Good. Chalo. Moving to the next one, beta. I'll not be here for this. I'm giving you poll, because beta boron family is not important. It is hugely important. So because boron family comes just after D block, and therefore the most anomalous and notorious family. So please give for this one. Please give an answer for this one. Sir, will you take chemistry for NEET in this channel? Right now I'm taking, Arjuna. So you want me to take more or what? If yes, then post the live is done. Put that in the comment section, and definitely we'll be considering it. Chalo, perfect. People are giving answer. So for this one, I guess 3 is your right answer. 75%. But let me make you revise this, beta. Now, because we know this group 13 comes directly after filling of D block, therefore this is the most notorious group. Z effective is increased, but sir, it will increase post 4th period. So Bagan, Aloo, Gajar, in Thela. Radioactive one we do not take. So if you talk of atomic size, then sir, atomic size should increase down the group. But Z effective of this gallium and this thallium will play into effect. But yes, now this is a factual and experimental data that you should be familiar with, that the anomaly definitely happens, but it only happens for aluminum and gallium in case of atomic size. So boron will be least. After that you will be having gallium. After that I'll be having aluminium, and indium and thallium follows the same suit of periodicity. There is no anomaly if you talk of atomic size. But I'm not saying the Z effective is not increased. It is increased, but it do not show its effect once you see the value of atomic size. So this should be the order of your atomic size. So boron, gallium, aluminium, indium and thallium. Option 3 is your right answer. But if I talk of ionization enthalpy, then ionization enthalpy will have impact on both of them. Impact on both of them as in, because of increase of Z effective in of thallium also, because here the F is filled for the very first time, so its Z effective will be huge. And because the Z effective is huge, now if you talk of the ionization energy, it will show its effect. And the effect is actually shown as that highest is definitely of boron. Down the group it will definitely decrease. But who comes second? This guy. So thallium comes second. After that the periodicity happens. What is the periodicity? So gallium and aluminum is obviously altered. So after that you have gallium, next you have aluminium, and at the end you have indium. This is for ionization. Similarly, one more property beta, periodicity of electronegativity, which is not a property, it is a tendency. So a relative scale is defined. The famous scale is Pauling scale. Sir, as size increase down the group, the general trend, so the electronegativity should also, sir, decrease. But again, that thing will play into effect. So who has the highest electronegativity? Boron, approximately 2.0. But now again the increment of Z effective will play its effect. And what is the fact? Now how to learn it? From boron, because for every pair you will be having that effect, increment of Z effective. So start doing that rhyme from the bottom. So after boron, bagan, alu, gajar, in Thela. To post that, you just reverse your order. So that should be the order of the electronegativity. I hope everybody is clear. I hope everybody is clear. Please remember these points, beta, very important. Chalo. Moving to the next one. The pair that has similar atomic radius. Sir, it is talking about lanthanoid contraction that we have already seen. So for lanthanoid contraction, what we have? So 4D series and 5D series elements will have same size. If you just do your rhyme, molybdenum and tungsten will just fall beneath chromium, and therefore their size will be same. So that should give you your answer. Moving to the next one. Which one of the following represent isoelectronic species? So what are isoelectronic species? Species having same number of electrons. So I mean, yes, you can explore the options. You should definitely explore the options. Get these lecture notes where PW NEET English channel or PW NEET English WhatsApp channel, or if you have subscribed, if you have participated in the free RE-NEET test series, then these notes will be definitely uploaded in the app too. So make sure you are attempting these questions properly, beta. 30 seconds to you. Quick. 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 I'll not be giving you poll for each question, but yes. Yes. D. Good one. Good one. Chalo. So what is D? Sir, calcium, 2 gone, so 18. Argon is definitely 18. Potassium, alkali metal, 19, 1 gone, 18. Chlorine, 17, 1 gain, so 18. So definitely D is your right answer. Happy to see that. Let me see 100%, 75%. No worries, no worries. Moving to the next one. The element expected to form largest ion to achieve the nearest noble gas configuration. Now, we only compare size of isoelectronic species. As you become more and more ionic, some protons are still the same. Electrons once increase, they may get filled to an outer electron, or because the charge outside, the negative charge is increasing, the number of protons are still the same. Therefore, more be the anionic charge, larger be the anionic size. Conversely, if you start losing electron, the nuclear charge obviously is still the same, so Z effective increases. So more and more cationic charge you gain, the smaller cation size becomes. So because you are talking of the largest ion, so just think of the anion. Sodium forms a cation, so this is wrong. This is 2 minus, this is 1 minus, and this is 3 minus. So more be the negative charge, the larger will be the anion. Perfect, perfect. Moving to the next one. Arrange the following elements in increasing order of first ionization enthalpy. Now for such questions, you should just do the periodicity, which we have already practiced. So kindly check, because beta, periodic table is actually a point which students, they don't pay much attention to, but actually they give a question, at least 2 to 3 questions they give in your complete inorganic packet, and they also help you to learn inorganic by yourself. So I'll be giving you some homework questions also. Because we'll be winding up around 4:30. So whatever number of questions and related concept we can practice, we will definitely practice. And yes, I'll be giving you homework questions also. With those homework questions, you can practice back at home also, because I have selected highly probable questions. So please do that, so that you may gain that extra confidence also. है ना? Chalo. Now, I hope most of you have got the answer, which is D in this particular case. No, less percentage. So let me tell you this. Arrange the following elements in order of ionization enthalpy. So sir, place them. Okay. So lithium, alkali metal. After that, I'll be having beryllium. After that, I'll be having boron, carbon, then nitrogen. Sir, definitely we know atomic size along the period decreases. So nucleus attraction will increase and ionization energy should increase. So who will be having highest ionization? So nitrogen, it is nitrogen should have highest, so option 1 is gone. Then carbon, then boron. Yes, if you just compare beryllium and boron, then ionization energy is also dependent upon the electronic configuration, because the electron has to remove from the stable fully filled configuration of 2s2, and for boron it will be a partial configuration of 2p1, which is obviously less stable. Moreover, penetration of 2s is, because as per n plus l rule, 2s is of less energy, so you have to supply more energy. So there will be a swap between the order of their ionization enthalpy, and hence nitrogen should have highest, post that you should have carbon, and post that you should have beryllium because of that reason, and therefore option 4 will give you a right answer. So I hope, perfect. No worries beta. Ananya, no, I mean, you are saying sorry beta, please make mistakes today. Please make mistakes as much as you can before 21st, so that whenever you commit a mistake, at least that thing stick to your head for a longer duration, so that you will not be committing those errors in the D-Day, the 21st of June examination. So no worries beta. Chalo, moving to the next one. Which of the following represent the correct order of metallic character of the given element? Sir, metallic character, then again go for that periodicity nature. So silicon, beryllium. So beryllium, sir, second period element. Then magnesium, just beta mange, down the group alkaline earth metal. Then potassium is 19, so it will be a fourth period element, but alkali metal. Then silicon I'll be having somewhat here in the P block. Now, sir, it is talking of metallic character. So, who is a metal? Sir, down the group size increases, metallic character increases. So, which shall act as a best metal? Sir, down the group, alkali metal. So, potassium wins. So, these are gone. After that, sir, beryllium, magnesium should be highest. So after that, magnesium, both options are magnesium. After that, sir, beryllium, because although its oxide is amphoteric, but ultimately it has only 2 electrons, and as you move along the period, in the especially the p block, you find the non-metallic nature. So silicon will be most least, not most, but among them electronegative. So here, least electropositive. So option 1 shall be your right answer. I hope everybody got that. Perfect. Ananya is saying, Acha, Archie is saying B. Archie, I hope you are clear now. Chalo. Moving to the next one. If first ionization enthalpy of element X and Y are these. Okay, these are the first of X and first of Y. And the second ionization enthalpy, okay, for X it is from 400 to 3000. For Y it is from 500, 600 to 1200. So not even doubling. So that means it is very easy to remove the second electron from Y. Sir, that means it is very much willing to lose that second electron. So it is a characteristic of alkaline group 2. Because after losing 1, it will love to lose 2. Hence, the value is not even double. But after losing 1, X is requiring so much of extra energy. That means X must have attained a stable electronic configuration. So that means X will definitely be an alkali metal and Y will be an alkaline earth metal. A very basic question, beta. Not D. Not D. Chalo. I hope everybody got it. Not D. It is option B. Moving to the next one. The third ionization enthalpy. Now you have to give the third ionization enthalpy and it has to be minimum. So it is minimum for whom? The cobalt. Sir, how to crack such questions? Beta, we have explained. We have done so much of periodicity. So yes, Henry, Bombay. Why? Because Fe is 4s2 3d6. So once 4s2 electrons are gone and once 3d is also gone, the third ionization enthalpy will be minimum. Why? Because post losing these 2 electrons, if the 1 electron is lost, it will become 3d5, which is a stable half-filled configuration. So this iron will be very much loving. This iron will be very much loving to attain this half-filled electronic configuration. Hence, the amount of energy required, that is delta H ionization third, will be quite less. So it will have minimum value. So perfect, everybody. Perfect, everybody. Moving to the next one. Chalo. I'll give you. Hello. For this. Okay. For this, I'm giving you 30 seconds. Because from this, you will also be getting some logic of S block. Chalo, quick. Yes, beta. Beta, we are not, you are not going to go for an advanced examination, Henry. If you want, we have done a advanced question discussion on PWJ English channel, I guess 2 or 3 days back. But beta, that will not be helping you because ultimately you are going to face 180 questions and time is 180 minutes. So speed and accuracy is your piece of job, my friend. Speed and accuracy is your piece of job, my friend. Else you should attempt JEE Advanced. It will definitely help you. Although JEE Advanced also this year, if you talk of chemistry, organic was quite good. But yes, if at all, Henry, you are having time, so watch that JEE Advanced paper discussion. It will be helping you conceptually a lot. I'm not sure how much it will be helping you for your NEET examination per se, but yes, conceptually speaking, you will be getting a lot of confidence. Chalo. Students are answering. I hope time is done. Yes. So C is your right answer. Most of the students are saying that an option, but it is 70%, so it's good. Chalo. In which of the following electron gain enthalpy are nearly same or identical? Now, you should always learn this. inert gases have positive value of electron gain enthalpy, and what is the trend? It decreases down the group. For yes, that is as per data only. And instead instead of having the least value, the value of neon is exceptionally very high, somewhere around plus 116 kilojoules. So please remember that trend, and definitely if you have that data in your mind, then argon and krypton has not approximately but exactly same value. So argon and krypton has in 1 and 3. So option 3 is your right answer, which is definitely a clear-cut NCERT data analysis that you should know. Only then you should do such questions. So I hope everybody got it. Chalo, give me the exact order now. I'll be helping you with the values also, because very important. So take the time and give me the exact order for inert gases. Obviously we have said that the value is positive for all, but if at all it is positive, what is the value? What is the trend? Yeah, perfect. So I hope you are doing it. Let me give you the trend also. So neon having the highest, it is plus 116 kilojoule. Then है ना अगर कर 0, I'm not taking radon, although the value also you can take, and then you have helium. These values are, let me help you with the values also, because beta, it is important. These are both 96. Helium is least, it is somewhere around 48. And xenon and radon, xenon, acha, radon value I do not have with me. So xenon, it is 77. Radon, it will be somewhere around 77 to 48, but still you should remember this pattern beta, a very famous NCERT fact. So that will definitely make helium as lowest, neon as highest, and among krypton and xenon, both argon and krypton has same, but xenon has a greater value. So krypton has a greater value. So krypton has a greater value, xenon has lesser. So option 3 is your right answer. How you should learn it? Just bring helium at the bottom. So what is the rhyme that you remember? Hai na agar kar 0 run pe. Just put helium at the bottom. And what is the periodicity? It should decrease, although it is positive. Why? Because these inert gases will never try to, because whenever you try to remove electron, you have to give in some energy. And here we are talking about their delta Heg. That is, sir, ionization is always endothermic. Electron gain in general is always exothermic, because whenever you gain an electron, you generally release energy. But for inert gases, because of stable electronic configuration, and for nitrogen, which is also half filled also and small also, their value is in fact positive, because they do not want to gain electron. If you want to give them electron, then you have to give energy to excite the already present electron, and then when space is created, then only they will accept electrons, else their electron gain enthalpy is endothermic. Again, for electron gain enthalpy, there is an anomaly. For electron gain enthalpy, there is an anomaly for most of the second period elements. Why? Like oxygen and fluorine, because of their small size, although they want to gain electron, but they have very limited space, and therefore a space has to be provided. Therefore excitation energy has to be given. So they will release much of energy, but a part of that energy is utilized for the excitation. Hence the second period elements do not have the highest value of delta H electron gain in their respective period. In oxygen family, sulfur wins the race. In halogen family, chlorine wins the race, because fluorine and oxygen, because of their small size, loses to have the highest value of electron gain. But still, the value is still negative. The electron gain is positive for inert gases, and it is positive for nitrogen. So again, a very famous trend for your examination. I hope you have read it. Moving to the next one. A traditional question. Acha, I have not checked option for that previous one. I guess it is C. So still good percentage, beta. Now, again talking of electron gain, so taking one electron is obviously electronegative, but after gaining that extra electron you have become a negatively charged species. Sir, minus will always repel minus. If you try to give that electron to a already negative species, this minus minus will repel, so this second process will always be endothermic. This second process will always be endothermic, and why it is endothermic is the reason is asked. So electron repulsion outweighs the stability gained by achieving noble gas configuration. Although you gain noble gas configuration, you will require that stability, but ultimately in order to accommodate the incoming electron to an already negative charge species, you have to provide energy so that the already present electron can be excited, and it creates a space available for the incoming electron to be getting adjusted. You will be getting the stability post it has came to you. Till the point it is coming to you, you have to provide energy, and providing energy is excitation of the already present electron. So therefore, what is the theoretical reason? This. And you should always keep in mind that if you try to remove electron, whatever be the electronic configuration, successive ionization enthalpy is also increased, and successive electron gain is always endothermic, no matter if you gain electronic configuration. A very important point. I hope everybody in sync with this. Moving to the next one. Now, attempt this one, giving you 30 seconds for this too. A basic question from periodicity again. Then we'll be, just after 2 questions, we'll be moving to chemical bonding. Good. हाँ, खाना नहीं खा सकते, कॉफी पी सकते हैं. Yes, even I can do that. You guys can also do that. Perfect. Sir, please pray for our victory in RE-NEET examination. Beta, we are working for your victory. So obviously, work is worship. So in a way, we are definitely praying. And beta, if you work, you do not require those. Energy always helps. So beta, yes. Cheers to your best result. Yes. Chalo, come on. Shoot. Good participation, guys. Good. Good. अकेले अकेले आइसक्रीम. अच्छा, नहीं नहीं, it is coffee, beta. Chalo. So I guess you are done. Let us explore the question first. Arrange the following elements in order of increasing electronegativity. So sir, again you have to plot that because they are belonging to different categories. So nitrogen, oxygen, fluorine, carbon will be here, and silicon will be here. So we have to talk of electronegativity. So electronegativity increases along the period and decreases down the group. So who will have least? Sir, silicon. That means these are correct. Who will be having highest? Fluorine. After that, oxygen. Because in electronegativity, it is just a tendency. So there is the electron gain, the ionization may vary because of stable electronic configuration, but for nitrogen we already know because of its stable electronic configuration it will not be that much interested to alter its configuration, and there is no anomaly also. So obviously among oxygen, nitrogen is less. Among nitrogen and carbon is less. So option 3 is your beautifully right answer. Right? Good, guys. Chalo, perfect. Moving to the next one. Acha, let me see the percentages. Good, 85%. Fair enough, beta. Chalo. Next one. The correct sequence given below containing neutral, the famous neutral oxides, carbon monoxide, CO, nitrous oxide, N2O, laughing gas, and nitric oxide, NO. They are your famous neutral oxide. Let me write them. CO, N2O, and NO. Just learn them, very famous. Now, non-metallic oxides are acidic, and if a metal is having very high oxidation state, then also it can become acidic. So among the given options, NO is here, obviously zinc is not neutral, so one option got eliminated. Now, what are metallic oxides are generally basic, and what are generally amphoteric oxides? We have a rhyme, Suno Zanabe Ali. Let me give you a rhyme for amphoteric oxide. It will make all your questions correct. Suno as an SN, Janabe Ali as in zinc aluminium, or unke is nothing, it's just a rhyme for the mnemonic. Bekar, Be as in beryllium, Kar as in chromium, ma'am, bhai. Who are these brothers? Just the element next to these three. So beneath tin, you have lead. Beneath zinc, you have cadmium. Beneath aluminium, you have gallium. So these all metal form oxides which are amphoteric. Yes, apart from that, you also have as in sub TV. So as in arsenic, sub as an antimony, TV, tellurium, and vanadium. Yes, vanadium oxide is controversial sometimes, but if you just remember these beta for your NEET level of examination, it will be done. Yes, for chromium, you should always remember chromium +3. At +3 state, it is amphoteric. If you talk of chromium in +2 state or chromium in +6 state, then sir, +6 is very high positive charge. Plus will try to gain electron. Gaining electron is acidic nature. So +6 becomes acidic. +2 wants to become +3 because +3 is stable T2G configuration. So this wants to give electron. Giving nature is basic. So actually, who is amphoteric? Not all chromium. Chromium in +3 state is only amphoteric. I hope everybody is getting this. Now, that means, sir, among them, zinc is already there and zinc is given in the option. So amphoteric one is zinc, neutral one is NO. Acidic oxide is definitely carbon in +4 oxidation state, and basic oxide is a metal oxide. So option 4 is your right answer. I have not given you poll for this because I wanted to tell you these oxides. A very important point. Again, now we have already discussed, more be the oxidation state, more is your tendency to gain electrons. So metal generally are basic, but D block metal, if they attain that maximum oxidation state, they turn acidic. So vanadium +5 will be most acidic, then +4, and least will be +3. But in the question you are asked the basic nature, so obviously this will be most acidic, hence least basic. So option 1 will definitely give you a right answer. I hope everybody is done. Now let us move to a chapter which will give you at least 3 to 4 questions. Moving to chemical bonding. And what chemical bonding? Sir, we'll be doing a whole of chemical bonding, but how? With questions. Why? Because we want to maximize the efficiency for this particular class of inorganic chemistry. If you find any problem, hit me in the comment section. I'll be giving you the complete, but definitely I'll be giving you theory by myself only, so don't worry. But still, if you find any problem, you can obviously ask, है ना? Chalo. Moving to watching from Kanyakumari, Tamil Nadu. Perfect, beta. Lots of love and respect for your efforts, sir. Ananya, that really moved me, beta. Good. Best of luck for your efforts. Best of luck for your efforts, and this is the thing I love about this platform. So good, beta. Hats off to our founder Alak sir, and hats off, beta. Good. Chalo, beta. Move on. Because we are starting with chemical bonding, so the first question, giving you 30 seconds for this. Time starts now. Quick. See, Robin is from Kashmir, Ananya is from Kanyakumari. So we are having students from Kashmir till Kanyakumari. So we are quite national. है ना? Chalo, good one. Beta. So starting with chemical bonding. I hope the time has ended. So let us explore the question. Among the following, the total number of species not having 8 electrons. So a basic question that decides this beginning of atomic structure of chemical bonding, that atom exists in nature to complete their octet. That was octet rule, but yes, there were quite limitations, and that's why post that we developed VBT. So nitrogen is having complete octet, so no. AlCl3 is definitely having 6 electrons, so acha, you are supposed to give the total of not having. So yes, AlCl3 is not having. BCl2 is also not having. So this is electron precise, having 8 electrons, so not an answer. And this is having 5 plus 5 is 10. So this is expanded octet. So how many expanded octet? So this is your not following, this is not following, and obviously this is expanded, so not following the octet rule. So 3 is your answer. See, 3 is your answer, but it is written in option 2. So option B giving 3. So good one. So I guess Bombay is your right answer. 16%. I hope it is now clear to everybody, beta. Chalo, moving to the next one. Molecules obeying octet rule. How many of them are, which of them are following octet rule? Sir, obviously carbon family always, carbon form always compound which follows octet rule. So CO2 is also having complete octet, CCl4 is also having complete octet. That means A is definitely 4. And if A is 4, then 2 options are eliminated. Molecule with incomplete octet. So incomplete octet is obviously boron and aluminium family. That means B is 2. That means B is 2. So with just this, we have got our answer. But still we are learning, so let's do it. Molecules with incomplete octet. Sir, NO, nitrogen double bonded O. So this will have an odd electron. Sir, NO2, nitrogen double bonded O, coordinated bonded O, because electronegative elements, you first complete their octet, and nitrogen will again have an odd electron. So yes, both of them have odd electrons. So this is definitely 1. And molecules with expanded octet are sulfur and phosphorus, because they have empty D, and that empty D can have the expansion of octet. So I hope everybody is clear. Moving to the next one. Now, predict the correct order. So, structure of molecule is decided as per valence shell electron pair repulsion theory, which says that lone pair electrons are far apart. After that, lone pair bond pair, because the repulsion is relatively less, and least repelling electron pairs are bond pair. So most repelling is lone pair. Then we have lone pair, and least is bond pair. So obviously option 2 is your right answer. Moving to the next one, the hybridization of atomic orbitals of nitrogen. Okay, so we have to give about the hybridization. NO2, nitrogen odd electron will definitely gone. So this is double bonded O. This becomes your coordinated bond O, and this is nitrogen. The only electron it is having is lost. So it will be just having 2 sigma bonds. So hybridization will be sp. So NO2 is definitely sp. So 2 options are gone. Now, sir, ammonia is definitely sp3 because 4 sigma bonds, nitrogen having +1, so no lone pairs. That means that is definitely sp3. So it is sp3. So option 3 is your right answer. But still, let us explore about NO3 minus, the nitrate ion. So double bonded O, then a single bond O minus, nitrogen octet is complete, but I can make a coordinate bond. So this will complete the octet of this guy as well. It is having no unpaired electrons, so its shape will be trigonal planar, and hybridization will be sp2. Definitely we have got the answer. I hope it is correct. Chalo. People are answering beautifully in the comment section, beta. I'm trying to utilize this time to the best of the efficiency. Hence, I'm not giving the polls. Yes, I'll be giving some polls for few questions, but not for all. I hope you can hit that comment section with whatever answers you are getting, and that will keep the session also interacting. And whenever you have any doubt, you can obviously put that doubt in the comment section. Okay, Ananya. Okay, we have Shibar. Sir, I am Ananya from Chandigarh. Awaiting in 4th June batch, the Yaqeen batch. please kindly update. Beta, Yakin will, I mean, yes, because of the re-NEET, we definitely have, you should definitely have also a compassion, beta, that yes, because of the re-NEET, we are just, it is just shifted by a week or so. But yes, we'll be coming up with the update soon enough, so don't worry. Although you can join over here and can do the preparations, I mean, the connect you can build from here only, because ultimately we are going to do every these things in the batches also. So don't worry, but yes, be compassionate, beta, because there are students who have given their examination with best of their efficiency, but still they are going to give a re-NEET examination. So we are just holding all those things because of this re-NEET thing, and definitely not at all normal job it is, because it is your life, है ना? So just be compassionate, beta. We'll be definitely moving forward, है ना? With the Yakin batch. Chalo. Now, for this question, again, application of VSEPR theory. So I want you to at least invest 30 seconds on this. So read the question, because statement-based questions are always a thing where students require practice, because you have to read. So read. Casper is from Kerala. So Casper, welcome, buddy. I have seen that name quite a few times in the lives. So welcome, beta. I hope you are doing great. Sir, I am also giving re-NEET. Ha, Ananya. Okay, that's good. That's good. Ha, 2. Karan Yadav. Karan is back. Karan is back. Okay, so people are answering 2. Yes. So let's do it. Let us check, because students are answering 2. So maybe 2 is right. We'll see. 75% good enough. For ClF3, all three structures may be drawn as follows. ClF3 is this, ClF3 is this, ClF3. Acha, maybe for ClF3, all three possible structures may be drawn. It is saying may be drawn. It is not saying they are stable structures. Can you draw them? Whether they are correct or incorrect, yes, you can draw them. So yes, statement 1 is, because it is saying may. So yes, statement 1 is correct. This is correct. Structure 3 is most stable. No, sir. This is AB5 type of molecule, and in AB5 type of molecule, lone pair always occupy equatorial position, because equatorial position, because it is at maximum bond angle of 120 degree, and that 120 degree creates at least the minimum repulsion between the lone pair cloud. And here it is equatorial. No, sir, here it is at axial. So this 90 degree repulsion will be happening. Here more of the 90 degree repulsion. So this will be least stable. This will be intermediate, and this guy will be most stable. So ultimately, what is my thing? So structure 3 is most stable. No, sir, this is definitely incorrect. So statement 1 is true and 2 is false. So 1 is true and 2 is false. Option 2 is your right answer. So make sure you are reading questions properly before attempting them. Moving to the next one. Chalo. Again, an application of VSEPR theory, beta. So giving you time to attempt this as well. Quick. Yes, Karan. Shape will be bent T. Perfect. Good one. Keep on working, guys. No electricity from morning. Okay, beta. This happens at most of the places. Even in my town, electricity keep on coming and going. Now we are third economy or fourth economy. That's why, na? Eh? So Acha, this is good, yaar. That means people, I regularly see these How to work for physical chemistry. Beta, I have already done physical chemistry sessions in my previous classes. Tomorrow, we'll be having a 500 MCQ marathon also for physics, chemistry, and biology. And there also I'll be discussing the remainder of the physical chemistry chapters, the class 12th that is left. So just go to the recordings, beta. I guess the two recordings that I have done for the two live that I have done for physical, they are for physical chemistry only. So they'll be helping you like anything, beta. Huh. Good. So that means, Mr. Rishi Sonak, I have become a bit popular now, because now in my classes people promote their name. So good. I'm happy. Chalo, moving forward. Now, acha, I guess most of you have answered this. Answer to this one is C. 100%. Fair enough, beta. Ammonia is definitely trigonal pyramidal because of that lone pair. Bromine, not bromine having 5 bond pair but 1 lone pair, so it will be AB6 with 1 lone pair, so it will be square pyramidal. So this will be square pyramidal, as in B is 4. XeF4, xenon having 4 bond pair but 2 lone pair. So again AB6 type, but 2 lone pair will be opposite to each other, so it will be square planar. So definitely C is 2. And again left is SF6, so 6 bond pair, no lone pair. So this is a bit octahedron. SF6, therefore it is beta. SF6 therefore is even used in circuit breakers these days. Why? Because this is an inert gas, it do not react chemically, and therefore SF6 is a perfect tetrahedron which protect the +6 state of sulfur and do not allow the sulfur to interact with anybody. So it is also considered as an inert gas, SF6 molecule. Hello, moving forward. Again the same question, but yes, let us practice this also without a pole. Ammonia, sir, we have already seen it is trigonal pyramidal. That means A is definitely 3. ClF3, sir, we have seen that also. This is bent T, 3 bond pair and 2 lone pair. So this is bent T or simply T-shaped molecule. PCl5 is having no lone pair, so it is trigonal bipyramidal. So C is definitely 2. And then I have BRF5. So 5 bond pair and a lone pair, which will again make it square pyramidal. So I guess option 3 is your right answer. C. Quick, right, guys? Good. Chalo. Perfect, beta. Moving to the next one. Acha, not this one, beta. Let us explore this question. Quick. Giving you 30 seconds for this as well. I'll be sharing this PDF, beta. Please, I will be leaving some questions so that you can take these questions as a homework practice. But because I have selected these questions, I mean the team has selected these questions, highly probable questions, so I really advise you to at least all of them very properly, beta. Okay. Karan Yadav, okay. Perfect, good, beta, good. So let us explore this question too. The question says, the correct increasing order for bond angle, sir, BF3 is a trigonal planar species with bond angle 120 degree. So the bond angles, hai na? Then phosphorus having 3 fluorine, and definitely it will be having a lone pair as well. So the angle will be definitely less than 109 degree 20 mm. This is 120 degree. This theta will definitely be less than 109 degree 28 minute, although for phosphorus hydrides we even know the Drago's rule, which says they are approximately 90 degree. But yes, 90 degree is also less than 109 degree 28 minute, but that is Drago's rule is not generally asked, so it is not even this is a JEE mains question, so not asked, but still telling you that. Now ClF3, sir, chlorine will have 2 lone pair, that will be positioned in the equatorial position. Then this fluorine and a bent T-shaped molecule will be formed. So who is having highest bond angle? Sir, definitely BF3. So BF3 is definitely having highest, which is only in one option. So I guess just with this option elimination, and obviously I've given you the logic also. So 100%, fair enough. Very good, very good, very good. Keep rocking, guys, keep rocking. Moving to the next one. The correct order of dipole moment. Now, dipole moment is net vector addition. So ammonia, a lone pair. Even beta, this JE Advance, this a paper on 17th of May, there was a question for comparison of dipole moment of ammonia and NF3. The very famous question. It was an advanced question, just 17th of May. So ammonia, sir, this is definitely polar because plus minus for nitrogen also, and it will be supporting the lone pair cloud. So it will be having a net mu addition. H2S is definitely a bend shape molecule. And here also I have these lone pair, but because nitrogen is more electronegative, so it will have a more net dipole moment. So methane is a tetrahedral symmetrical shape, so its mu net will be 0, so this will be non-polar. And HF is also a linear molecule with fluorine having highest electronegativity, so net dipole moment will also be highest because fluorine, the magnitude of charge will be highest. And yes, because of that, you can obviously see what option is given. Methane is definitely lowest. So these are the options. Post that, sir, HF, highest electronegativity, then nitrogen, and then sulfur. That will make option 4 as your right answer. I hope everybody got that correctly. Moving to MOT beta. After this, the next important topic is molecular orbital theory for us. So the correct molecular orbital picture for nitrogen, sir, sigma 1s, sigma asterisk 1s, sigma 2s, sigma asterisk 2s. Till here everybody is giving same. Now for elements which are lighter, sir, 2s 2p interaction take place and restructuring of energy happens, as a result of which the energy of 2s decreases and energy of 2p increases. Because 2p increases, so sigma 2pz becomes of higher energy. So pi 2px and pi 2py is filled first, then you have sigma 2pz, and then definitely the anti-bonding molecular orbitals, which is pi asterisk and sigma asterisk. So option 2 is your beautiful right answer for oxygen and fluorine, and for all the heteroatomic species having electrons more than 14. The MOT of oxygen is followed, which is just the reverse of this, which is just these two are replaced. For nitrogen and lighter elements, this electronic configuration is followed. So for this, I guess option 2 is your right answer. And with this, we have revised MOT also. Now let us explore more questions from MOT. So attempting this one, let me give you 30 seconds for this, because if at all you have any doubt, you can post that doubt and I shall take that, or else we'll be just maintaining our pace. Good. So attempt this one, guys. Attempt this one, beta. Chalo. Good, 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 good. I can see. Chalo. Very good. Yes. Perfect. So I guess time is done and most of you have got answer as well. 80%, fair enough. Let us see what is there in this. Which one of the following pair of species have same bond order? Sir, you can calculate bond order with MOT. The MOT I've already told you. Now, apart from that, beta, for heteroatomic molecules, I am telling you, actually, MOT is only valid for homonuclear diatomic. It is anyway extrapolated for heteroatomic molecules, but generally for heteroatomic molecules, you should calculate their bond order using VBT in your mind. Now, what is this VBT? Sir, Cn minus C triple bonded N. VBT says any atom forms bond to pair their unpaired electrons. This carbon, if gains one electron, will have all the electrons pair. Nitrogen is anyway having paired electrons. So, sir, bond order 3. What about carbon monoxide? Sir, carbon double bonded with oxygen, so octet of oxygen is complete, but carbon octet is not complete. So just make the coordinate bond after formation is similar to that of a covalent bond, so replace it by a covalent bond. But once doing it, you should always put the donor atom is obviously giving electrons, so it will gain a positive charge. So this nitrogen, oxygen has become just like nitrogen. Carbon gaining that extra electron will make it negatively charged, so it has also become like nitrogen. So this is also N triple bond N like structure. So both of them has same bond order. Yes, you can do it through molecular orbital theory also, but I would rather say for heteroatomic molecules, just settle yourself and come up with a quick answer using VBT for heteroatomic molecules. Else for homonuclear diatomic molecule, you can obviously make their electronic configuration, then do Nb minus Na upon 2. What is Nb? What is Nb? Number of electrons in bonding molecular orbital minus number of electrons in anti-bonding molecular orbital. I hope everybody is good with this. Chalo. Moving to the next one, guys. Again, the same logic that we have explained for MOT, just explore this one, beta. Try to answer this one. Try to answer this one. Quick. Quick. Chalo. Quick. Quick, guys. Chalo. Beta, keep your work intact. Keep on working for yourself. That is for your better results. That will be helping you and your family to see you at a better stage. So at least keep on working for yourself. So I hope most of you have got the answer. Percentage is 100, so I'm super happy. Now let us explore why is it so. Sir, the question is just telling us that molecular orbital, the wave function, the LACAO, which is linear combination of atomic orbital, tells us that atomic orbital linearly combine and they form molecular orbital. But sir, according to quantum theory, these orbitals are wave function. So when wave function has constructive interference, the molecular orbital formed is stable because it is of less energy. But once they have destructive interference is mathematically shown by their subtraction of eigenfunction or the simple wave function. So psi a minus psi b will result in a molecular orbital which are of high energy and less stability. So they will be forming anti-bonding molecular orbital. That means A is definitely 3. Sir, on addition of on constructive interference of these orbital of these eigenfunctions or wave functions, or simply two electrons which are designated by psi, the addition will form a molecular orbital, and this small bonding molecular orbital will have less energy and more stability. So D is definitely 2. So D is definitely 2 and A is definitely 3. Okay, so we are still left with 2. Now, Nb minus Na upon 2 gives you bond order as per MOT. So, and bond order calculation is number of bonding minus anti-bonding electron divided by 2. So that means C is definitely 4. That means option C is your right answer. I hope everybody got that. Moving to the next one, beta. Chalo. Now, attempt this one. Giving you 30 seconds to this. Attempt this. Quick, beta, quick. We are just finishing with chemical bonding. Then we'll be moving to coordination and block chemistry. So this is 3:36. So we'll be taking 1 more hour and then we'll be finishing inorganic. But yes, I'll be giving you question problems, problems for practice also. It will be included in the same session beta. But yes, these notes you have to download from where I've already told you, from NEET PW NEET English WhatsApp channel, or if you have subscribed to RE-NEET free test series, then you can download these notes from the PW app as well. है ना? चलो, good, perfect guys, perfect. चलो, हाँ. Now the live chat has got silence because I have messaged to my people to chalo. Everybody is good, beta. Everybody is great. If it is working for your good, everybody is great. Beta, I've already mentioned. Karan, I've already put that thing in the comment section. That's why keep working for yourself and don't get distracted, beta, because keeping your cool is also a hot spot criteria for you being a successful doctor, because you have to keep your concentration focused. Will the people around not distracting you? Yes, they are meant to do it, but the person who remains focused enough is actually a true winner. So if you want that authorized, that disciplined and that successful white coat on your shoulders, then definitely beta, keep your focus intact, because you will be, everybody will be getting those distractions, but you have to remain focused for your best. Chalo beta, moving forward, I hope most of you have got this. Acha, I guess there's an option problem, beta, because this is pi. Okay, this will be, I guess, pi estic. So because it will be pi estic, so I beg your pardon. This was a typo error. Chalo. Let us do that, beta. Oxygen, sir. Oxygen is sigma 1s, sigma estic 1s, sigma 2s, sigma estic 2s. Then we have sigma 2pz. Then we have pi 2px equals pi 2py. And then we have pi estic 2px equals pi estic 2py. Now, how you should do it, do not write it every time, but yes, because I'm just giving you for the one time. So 1, 2, 3, 4, 5, 6, 7, 8. 9, 10, 11, 12, 13, 14 and 15 and 16. So these are the 16 electrons, and how you should calculate bond order. Don't sir, bonding, anti-bonding cancelled, bonding, anti-bonding cancelled. So why to do? Now they are 6 bonding and 2 anti-bonding. So 6 minus 2 is 4, 4 by 2 is 2. So bond order of oxygen is 2. Now, what change is happening once you gain 1 electron? So actually electron is gained in the anti-bonding. So that is pi estic 2px. That means 4 is your right answer. There was a typo error because both pi were bonding. So I have first corrected the option, and obviously now everybody will be in sync. Now this is but beta, a very probable logic, one question from MOT is definitely going to be there in your 21st June paper. Please remember this. Obviously, if you do, it's a practice, it's a revision. Moving to the next one. Now, given below are two statements. Statement 1 says, hypothetical diatomic molecule with bond order 0 is quite stable. If bond order is 0, sir, first of all, the molecule will not even exist in nature, because it is not the electrons are not even participating. But it is saying it is quite stable, so definitely it is incorrect. And as bond order increases, bond length, no sir, as bond order increases, two species get close to each other and bond length decreases. So they are inversely proportional. So obviously this is also incorrect, and because both are incorrect, so option 2 is your clear-cut answer. I hope everybody is in sync with this. Moving to the next one. Select the compound from the following that shows intramolecular hydrogen bonding. Intramolecular hydrogen bonding only takes place when there is case of chelation. What is chelation? Ring formation. When you can have that ring formation, beta, once you form a ring, a cyclic structure which is free from any type of bare strain. What is that bare strain? Whenever cyclization happens, bonds are forced to come close to each other. Who has minimum bare strain? Bayer has done statistical analysis, experimental analysis, and told that 6-membered ring are free from any type of strain. So that's why whenever you form a 6-membered, preferably 5-member can also have has minimum bare strain, but not 0. 5 and 7 has some bare strain, but yes, not 0, but yes, they have a bit of strain, but still 5 or 7-membered rings can also be formed, but best is 6-membered ring. So definitely with that logic, this oxygen minus and hydrogen plus can form that 6-member chelation effect, and then only you can have that intramolecular hydrogen bonding. A very famous point, and fair enough, most of you are answering also. Moving to the next question, the order of covalent character. So that means it is discussing about Fajan's rule. Now let us summarize Fajan's rule in just one line. Fajan's rule tell us that the covalent character in an ionic compound is decided by small b the cation, large b the anion, and more b the charge. Ultimately, the polarization power of cation allows and empowers the cation to attract the electron of anions also. But sir, because this is because the complete transfer is not taking place, so it is just like sharing. Because if you have Na plus and if you have Cl minus, then electron transaction has already taken place and they are ionic compound. But still, if you have Li plus instead of Na plus, then the polarization power of cation will force the electrons of anion to not completely align with itself, but to be interacting with the nuclear charge of the cation. So more be the polarization power of cation, more is its polarizability. And more large be the anion, more will be its tendency to get polarized. So this is the polarizing power of cation and polarizability of anion that decides the covalent nature in an ionic compound, which is definitely the Fajan's rule. So as per that, if I compare potassium and potassium fluoride, so cation is common, so anion will decide. Large be the anion, so because I minus is large, so I minus will be more covalent. Because it is saying less, so it is wrong. I minus is more covalent, yes sir, this is right. I minus is less covalent, this is wrong. Okay, so ultimately we have eliminated 2 options. We have to play with B and D. Now among lithium fluoride and potassium, sir, now fluoride is common, so decide with cation. Smaller be the cation because charge is same. So this lithium is smaller, so yes, it will be more covalent. So definitely B is correct. So B is correct. Now, what about C? Because we have to explore multiple options. Now, sir, D block cation is always more covalent than S and P block. Why? Because they have very strong Z effective. We have already done that, been there and discussed that thoroughly. So D block cations, because of their strong Z effective, has huge polarizing power. Hence, they are always more covalent than S or P block cations. So this is definitely correct. Talking about tin, sir, more be the charge. Obviously, more is the polarizing power. So this tin is in +4 oxidation state. Therefore, it will be more covalent. Therefore, C is also correct. So B and C are correct. That makes option 2 as your right answer. So with this we are done with chemical bonding. But yes, okay. So let me just save this beta because my system gets hanged if I directly import. So just by the time, if you have any doubt, just hit me in the comment section. Just let me save this one. It is saved. So now I can do what? Now because this is saved, so I'll be importing a new document for me now. That will be containing that will be containing the later chapters of your inorganic chemistry. So let's start the next chapters of inorganic. Bonding and periodic table we have done. We are done. Now D block more or less we have already done while discussing the conceptual side. So directly moving to the coordination compounds. Now quick beta. We'll be learning coordination compounds with the same manner. We'll be attempting relevant questions, and we'll be discussing concepts also while discussing them. So the first question, Karan, sir, para compounds show intramolecular hydrogen bonding. No, right? No, beta. Para can't have chelation, na, ring formation. Ortho shows. Para show intermolecular. One molecule can have interaction with another. So para nitrophenol have intermolecular hydrogen bonding, hence boiling point is more. Ortho has intra, hence boiling point is less. है ना? चलो, quick. अच्छा, I guess beta this is now you can attempt. It's a printing error. This one. So I hope, because I have given a printing error in a question, so obviously that will be the answer only. So option is definitely C. Let me see. Good percentage. So what the question is telling you, that which of the following set of complex and a double salt respectively. So what is a double salt? So double salt is actually a compound which is having obviously more than one cations and more than one anion forming a salt, and the salt generally crystallizes using some water of crystallization. But whenever you put that salt in water, it corresponds to the positive test of all the constituent ions. That means they are not associated with a strong force of attraction, while a complex compound do not show the whatever ions it has, it do not I'd make all the ions identified because they are strongly holded, and the strong hold is obviously because of the strong attraction force, which is due to the formation of a coordinate bond between whom? Between a metal atom or ion which is having empty d orbital acting as a positive charge center, and ligand as electron rich species which behave as electron base and coordinate their excess of electron on the empty orbital of the metal atom or ion. Now according to crystal field theory, you can just think of this coordination compounds as a plus minus attraction. Again, more be the charge density of cation, it will attract the electron rich ligands to the maximum of the efficiency. And whenever that anions are approached by this metal ion, technically as per your physics, as per Gauss law, it should have a symmetrical field. But sir, the metal ion is not a point charge, because it is having orbitals which are of different energized shape. The isolated atom is degenerate. The isolated atom has all the d orbitals which are of similar energy. But once it is approached by a ligand, the degeneracy of that metal ion gets disturbed. And in what way it get disturbed? Suppose it is forming an octahedron. So it will be getting disturbed. How? Sir, people are approaching me along the axis. So what all orbitals I have along the axis, their energy will increase. I am summarizing everything in just 5 minutes, beta. Yes, we'll be discussing questions after that, but let me summarize everything for you. So in case of octahedral complexes, what happens? Sir, the degeneracy of d block elements splits up, and the splitting result in the formation of less energized T2G set and high energized EG set. But this happens in case of octahedral complexes. So this crystal field splitting is known as crystal field splitting in case of octahedral complexes. Now, if you just compare them with the barycenter, then sir, energy cannot be created nor can be destroyed. If they have gone up, they have taken energy of whom? These three. So the energy distribution will be, they will be having, the EG set will be having higher energy, but what times? Sir, they have taken energy of these three. So it will be 3 by 5 times of delta naught, and this will be 2 by 5 times of delta naught. So mathematically speaking, this will be, if electron is acquiring high energy orbital, so the contribution will be 0.6 times of delta naught with a positive charge. This I am talking for the energy that they will be acquiring. So if I am acquiring more energy, I will be getting destabilized. So where the electrons will be filled first? and that will provide a crystal field stabilization energy. And how to calculate it, sir? Because it has a factor of 2 by 5, so this is 0.4 times of delta naught, but every electron acquiring this will have a negative impact on the energy, hence energy is reduced, hence stability is increased. Now once you form this octahedron, then you are approached by 6 ligand. If you are approached by less number of ligands, then splitting will be less. So what is the next famous number which compounds have existing in nature? 4. So coordination number 4 can have what possibility? You can either be a symmetrical tetrahedral molecule, but you can either be a square planar geometry molecule. So let us first discuss for tetrahedral. So for tetrahedral, the splitting again happens, but yes, the splitting is less in magnitude, and once you form a tetrahedral complex, the ligand will approach you from where, sir? From in between the coordinate axes. So whose energy will be more? The dxy, dyz and dzx, but in this case I'll be calling them as T2 set, not G, because G stands for gerade nature, that represents the symmetrical distribution, because the formed molecular orbitals, are not symmetrical, hence the G term is not written once splitting is tetrahedral, and the lower energy is definitely of E set, again not EG, just the E set, with this being the barycenter. And the splitting is termed as crystal field splitting in case of tetrahedral complexes. I hope everybody is clear. Now the magnitude 9 times of tetrahedral value becomes 4 times of octahedral value. This is a statistical NCERT data that you should know. That is the relationship between tetrahedral and octahedral splitting, which signifies that octahedral splitting is large in magnitude. Now this is just the complete theory. We'll be discussing a few more things as per the question availability. But now, so that means addition compounds are basically of 2 types: double salt and complex salt. Double salt is this, and a complex salt is like a platinum compound, because platinum, the crystal field splitting depends upon the ligand also. Generally, which ligand is of high splitting power? Sir, carbon donors. Less than that, nitrogen donors. Less than that, oxygen donors. And least strong ligands are halide donors. Obviously F minus will have highest among the halogens, and Cl minus will have and I minus will have least, because of obviously the electronegativity. But the sequence of splitting that we know statistically is through the spectrochemical series. So I hope I have summarized everything for you. Now we'll be practicing question. I'm not writing everything, but yes, I have. If you just go back to the recording of this session, in this, I guess 10 minutes, I have summarized the complete coordination chemistry for you, just like that. But yes, you need to attempt questions also in order to be efficient with your working. So obviously the answer for this question is option 3, because this represents a complex, because as you move down the group, for D block elements, the Z effective increases. So I am a super strong positive point charge, and therefore the complexes formed by metal cations of D block down the group, like the 5D series, they have so much of high splitting that it is indifferent whatever ligand you take, they always have high splitting, and high splitting is accompanied by what? Crystal field splitting. It is always accompanied by square planar splitting. Why? Because in magnitude, square planar splitting is in fact much larger than octahedral splitting. So therefore the platinum complexes, whenever they are formed, they are always square planar. So this is platinum with 2 chlorines and 2 ammonia forming a square planar geometry, and definitely it will form a coordination complex. And this is an alum potassium aluminium sulfate. I guess stoichiometry is incorrect in this option, but I hope you now have an understanding of what is a complex salt and what is a double salt, where all the ions are, once I put this salt into water, you can identify potassium ion also, aluminum ion also, sulfate ion also. But here these ions will never be determined, because they are strongly attracted to each other using a coordinate bond. The complete chapter is summarized. Moving to the application by discussing more and more questions. Chalo. So with this, because it's a statement based question, so giving you 30 seconds for this. Quick beta. Chalo, shoot. Quick. हाँ बेटा, मतलब I have not written, but I have given you. Okay, Ramya, Madhu, clear sir. Good beta. Good. Quick. Now the question says, huh. Now the question says, cobalt with 6 ammonia is homoleptic. What is a homoleptic complex when all the ligands are same? So yes, this is definitely homoleptic because 6 ammonia are ligands. Cobalt with 4 ammonia and 2 chlorine is a heteroleptic complex. Yes, because heteroleptic when more than one ligand are used. So statement 1 is definitely correct. Complex A has only one kind of ligand, but A has more. So this is obviously the theoretical definition also. So both are correct. That means both are correct. That means option 3 is your right answer. Option 3 is your right answer, 100%. Very beautiful beta. Good everybody. Moving to the next one. Now, which complex compound is most stable? So among them, you have to determine determine which one is most stable. Sir, the stability, you have already told us, more be the polarization power of cation. Polarization power depends upon, sir, more be the charge, and down the group, Z effective increases for D block, not for all, for D block. Sir, but here it is all 3D and all cobalt is in +3, so it is a tie. Now, sir, it depends upon the ligand. Stronger ligands are carbon donors, but apart from that, whenever you have a bidentate ligand, or maybe where denticity, where the nature by which you are making that coordinate bond is more than one, then you can have a chelation effect, a ring formation effect. So whenever you have a bidentate or a polydentate ligand which forms a ring with the metal ion, that chelation effect provides stability, and that stability makes ethylene diamine, which is a symmetrical bidentate ligand, the most stable complex. So a beautiful logic, and the logic is, more be the number of chelation rings formed, more stable is the complex. How we have came to this conclusion? Again, it is a statistical analysis, that once we start hydrolyzing these complex salt, which complex salt gets hydrolyzed to the to the maximum amount of dilution, the complex which is having chelation. So more be the rings, more stable is the complex formed. I hope everybody is clear. Moving to the next one. The correct order of ligand. Now again, for this also I have told you. So okay, just I've already told you although, but still I want you to at least read it once. Read it once. The correct sequence of ligand in order of decreasing field. So decreasing field as in which should be highest. Sir, you already told carbon donor. That too, if you have carbonyl, then carbonyl has synergic bonding. What is that synergic bonding? The carbon having the extra electron, once this carbon donates an electron to a metal cation to its empty d orbital, the metal cation also will be having some of the d which are filled with electrons. So that metal cation, now after formation of the sigma bond, there is a back bonding happening from the filled orbital of metal ion to the empty anti-bonding orbital, to the empty anti-bonding molecular orbital of CO. This creates a partial double bond character between them, and because of this partial double bond character, carbonyl, although CO is a neutral ligand, but still it is most powerful, it is having highest value of splitting. Therefore carbon donor react to CO is the strongest field ligand. Therefore obviously CO is highest, and after that I have told you nitrogen donor. Sir, we do not have any nitrogen donor. Then oxygen donor, so water. Then halides, and definitely sulfur is quite large and diffuse, so it will be least among them. So your best answer will be option A. Yeah, let me check how many of you have done it correctly. Perfect, 83%. Fair enough, beta. Fair enough. I hope everybody is in sync. Chalo, moving to the next one. Which of the following complex will show largest splitting of orbital? Sir, again, crystal field splitting. So check for the metal. Sir, metal is same. Check for the oxidation state. Sir, oxidation. First charge should also decide. Sir, charge is also same. Then who will decide? Ligand. So is any ligand, do you have any ligand? Yes, sir. Sir, carbon donor are strongest. So carbon donor is strongest. So that will make option 3 as your right answer. I hope everybody is clear with this. Quite doable questions these are, beta. Chalo. Moving to the next one. From the magnetic behavior of nickel +4, which is paramagnetic, and NiCO, which is diamagnetic, choose the geometry and oxidation state. Now let us explore this question. Very famous question. Please, please, please make sure you're reading, you're listening to me very properly. Now, nickel is 4s2 3d8. Oxidation state of nickel over here is +2. So 4s2 gone. So this is 3d8. 3d8 as in I have 8 electrons. So 1, 2, 3, 4, 5, 6, 7, 8. Now, chlorine is a weak field ligand. Generally, for octahedral complexes, what we have in our mind, for octahedral complexes, mind you, any ligand which is stronger than water as an oxygen donor. So those nitrogen, those ammonia, those carbon donors, they act as a strong field ligand. If at all metal is in +2 or +3 oxidation state. Yes, if it is a D block, if it is down the series like platinum, palladium, whatever is the ligand, even water acts as a strong field ligand. But yes, there is a catch, which is cobalt +3. For cobalt +3, just for this beta, please remember this, a very important point. Just for cobalt +3, learn this, that for cobalt +3, till oxygen as donor, they can act as strong field ligand. So not for all, for one element of 3D series, which is cobalt +3, carbon donor are strong field ligand for any 3D series element. Ammonia also become a strong field ligand for CO +3. Water also, that means nitrogen donor also and oxygen donor also, they can behave as a strong field ligand, not halides. Halides are always considered as strong field ligand even for cobalt +3 compounds. Why? Sir, because you already told us that the crystal field splitting depends upon the polarization power of cation. So this is the polarization power of this cobalt +3 cation. Yes. With platinum, because they are large, strong Z effective cations, they can even have strong field ligand, strong field splitting even with weakest ligand like halogens, but that is for large D block cations, है ना? So I am just summarizing everything for you, beta. Chalo. Now that means, sir, weak field ligand. So what hybridization will be taking place, sir? Because coordination number is 4. What is coordination number? Number of ligands attached. How many chlorines are attached? 4. So hybridization will be sp3, because no inner D subshell can be used. So they are also, the hybridization is sp3, and outer orbital complex will be formed. Although outer orbital and inner orbital complexes are basically used for octahedral complexes. Generally not for coordination number 4 complexes, for coordination number 6 complexes, but summarizing everything for you. Now, sir, nickel here is in 0 oxidation state. So this is 4s2, this is 4s2, and 3d8, 0, that means no electron is gone. But CO, sir, you have already told us it is a strong field ligand, so it will force the 4s electron to come inside. So here my D subshell will be having 3d10. So 1, 2, 3, 4, 5, 6, 7, 8, and 2 electrons will be forced from the 4s subshell. So this will have completely filled, but still, although force pairing is taking place, but no inner D subshell is empty, no inner D orbital is empty. So this will also be sp3 hybridized only. So hybridization is sp3 for both of them. So because sp3 hybridized, so both of them will be tetrahedral. But yes, oxidation state is 0 for carbonyl and +2 for that, +2 for nickel chlorine complex. So again, a very beautiful a very beautiful logic, not question, but logic. And with this logic, I have tried to explain you the complete crystal field splitting also, the relevant crystal field splitting. I hope everybody is in sync with this. Moving to the next one. Chalo. Now, a good question I want you to spend, good as in logically good question, giving you 45 seconds for this. Quick, 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 beta, quick. Quick. D. Okay. Henry, good. Ananya, D. Robin, D. Zainab, D. Perfect, guys. Chalo. Good. Good participation. Because all you people are saying D, so maybe D. Yeah, 100%. Perfect. Let us explore this beta. The question says, which one of the following complexes have delta crystal field? Now, delta naught means crystal field splitting in case of octahedral complex. That is 0. And magnetic moment. What is magnetic moment? Mu. Sir, under root of n into n plus 2 Bohr magneton. What is n? Number of unpaired electrons. So this we have to do now for these complexes. So let me directly, you can obviously check for every, but because everybody is saying D, so let me directly check for D. Manganese, sir, manganese is 4s2 3d5. Now what is the oxidation state? SCN minus is a negatively charged ligand with -1 charge, so x minus 6 equals -4. That means manganese is present in +2 oxidation state. That means this is 3d5. Now, sir, what about SCN? Sir, you have already told us that for 3D series, only carbon donors are acting as strong field ligand. Then, sir, this is a weak field ligand. So, with a weak field ligand, what splitting you can think of? Sir, 1, 2, 3, 4, 5. Sir, this is crystal field splitting in case of octahedral complexes, but because ligand is weak enough, so splitting will not be much large. But still, splitting will take place. Yes, sir. So this I have got the T2G set, this I have got the EG set. Now, how the electrons are supposed to be filled? Sir, 1, 2, 3. What about fourth one? It will be going here. Why? Because splitting is less. So pairing is difficult, and rather because splitting is less, because I am a weak field ligand, so I will rather occupy EG set. If the splitting was large enough, then I will be forced to occupy T2G, because I would be having much ease to undergo pairing, but here pairing energy is more. Therefore, I will rather do the filling of EG set, because crystal field splitting is less for a weak field ligand. That means how many electrons I have in the T2G set? 3. I have already told you what contribution every electron will make. Sir, minus 0.4 times of delta naught. So this is minus 1.2 times of delta naught contribution of these 3 on the EG set. Sir, what about the T2G set? Sir, what about the EG set? 2 electrons. Every electron will have a contribution of plus how much? 0.6. So 2 into 0.6 times of delta naught. So that is plus 1.2 times of delta naught. 1.2 it is, not 12. So this is plus 1.2 times of delta naught. Now you tell me this is minus, this is plus. Arey sir, that means whatever energy has been released has been absorbed. So crystal field splitting, crystal field stabilization energy will be 0 for this particular case. crystal field stabilization energy will be 0 for this particular case, and because it is 0, that means it is definitely correct for this. Now we have to check for bond order, how many unpaired electrons I'm having. 5. So under root of 5 into 5 plus 2 is 7. 7 5 ja 35. 35 under root is 36 is 6. 6 into 6 is 36. So just less than 6, which is 5.96. So definitely this is also correct. That makes option 4 as your beautiful correct answer, a very high probable concept for your NEET attempt beta. है ना? चलो, moving to the next one. Perfect. Now, next question. The number of species from the following that are involved in sp3d2 hybridization. sp3d2 hybridization. So just check everybody. I'm not giving poll for this one because chalo, let us check. Sir, cobalt plus 3, sir, you have already told us it will be a strong field ligand. So cobalt is 4s2, 3d7, 3 gone because cobalt is in plus 3. So 4s2 gone, then 3d6. So 3d7 becomes 3d6. So this is 3d6 with ammonia as strong field ligand. So force pairing will be taking place, and hence it will be d2sp3 because 2 orbitals will be filled in the inner d. So because it is not sp3d2, so not an answer. Yes, sir. SF6 is a simple molecule, so it will be definitely sp3d2. So this is because I have to select. So this is 1. Now, sir, chromium, sir, fluorine is a weak field ligand. Coordination number 6, so definitely it will also be sp3d2. Do not even have to check. Sir, cobalt. But beta, cobalt act as a, cobalt has good polarizing power. The splitting is large, but sir, nitrogen can act as a strong field ligand, not halogens. So this will also have sp3d2. Cyanide obviously is a strong field ligand, so it will be having d2sp3, so not an option. And manganese. Chlorine is also weak field ligand. So this can also be sp3d2. So this will also be an option. So how many? 4. How many? 4. Okay, so option 3, I guess, na? Just check, guys. And option 4 is the right answer. So we are missing any what? Option 4 is the right answer, beta. Let us check this again. Option 4 is the right answer. So that means we only have 3 people having sp3d2 hybridization. Cobalt, manganese, नहीं बेटा, chromium. D. क्वेश्चन ही नहीं आया यार मेरे पास. चलो, हाँ, so I guess cobalt is a strong field ligand. A cobalt plus 3 has got good splitting, but with case of nitrogen complexes, beta. So there I can do it, but with fluorine, no. For halogens, no. This is definitely not a case. Manganese is in plus 3. Acha, beta, manganese is in plus 3. So this will be 3d4, na? Or it is 4 minus or what? I guess this is a typo error in that case, beta. I guess there is a typo error. With this question, beta. So I'll just check this again because the options as per the option given, third will be, or else there will be some typo error. I'll just confirm it and I'll get back to you. Hai na? Chalo, moving to the next one. Yes, a good question. What? So Karan, beta, definitely. I'll be just checking that because if at all that was the option, then my answer is C. That means 4. Else you have to change because the answer written was also different. So as per the option given, if it is a typo, but sir, whatever is written, we'll consider that. So as per that, C was my answer. Chalo. Now, coordination entity, sir, you have already told us it has splitting of the metal ion. Now, because of that splitting, energy absorption can take place. Why? Sir, because if you have unpaired electron, it can easily get excited and make that DD transaction. Because of that DD transaction, whenever I'll gain some energy, I'll get excited, I'll give back that energy, I'll come back to my ground state, and will show you some color. That's why the D block and the coordination compounds are always colored species. So what? First of the point is, most 95% of the time your mains and NEET level of questions are done with just this fact that if a metal ion is having unpaired electrons, then the probability of those unpaired electrons to get excited in the presence of white light is quite high. So they will definitely show some color. But yes, color is not always because of the DD transaction. Sometimes the metal can transfer the electrons to the another metal, like in case of ferricyanide or ferrocyanide, the Turnbull color and the Prussian blue color is because of the metal electronic transaction. Now this is a good topic, but still I'm iterating everything. Then for permanganate and dichromate ions, sir, there also they do not have any unpaired electrons, but they are also colored. That is because of the electron transfer from the ligand to the metal, from the metal to the ligand. I mean, from metal ligand charge transfer. Because ultimately, if electron is flowing, delocalizing, taking energy, getting excited, but in order to get excited, I need an empty space. So that empty space can be between metal ligand, can be between one metal to another metal, and most of the time it is between a metal ion which is in itself having unpaired electrons and having that DD transaction. So for your mains or NEET level of questions, you should just learn, if at all your metal ion is having unpaired electrons, it will have a possibility and probability to show color. If it has all the paired electrons, it will have less possibility to show color. But I'm not saying it will never show color, because the metal electronic transaction and metal ligand electronic transaction can also allow the color to be visible to your eye. But yes, what color you absorb, you show the complementary color. And complementary color wagon wheel is this. Your simple wagon wheel you should learn is this, which is VIBGYOR, as in, if you absorb violet, you will show yellow. If you absorb yellow, you will show violet. So these are complementary color. Again, not a hardcore science, but yes, statistically, approximately it applies. Like if you absorb violet, you show yellow. If you show yellow, you absorb violet. If you absorb blue, you show orange. If you absorb orange, you show. So they are complementary wagon wheel. Many times they will make your question correct. Now, if the splitting is large, energy required for the excitation will be large. Energy is large, that means frequency is large. Frequency is large, that means wavelength is minimum. Now the question is asking you wavelength. Among them, who is the strongest ligand? Cyanide. So cyanide, strongest ligand, so splitting will be large. So frequency will be large, but wavelength associated will be minimum of the absorbed packet. So minimum wavelength is what? Sir, minimum wavelength is 1. So that means C is 1. So if you just go by C is 1, you will be landing with your answer. A very probable question, beta. It is going to come a lot many times. I'm not giving you polls now. Karan, perfect, beta. I'm not giving polls now because because I wish to conclude by 4:30, है ना? So yes, I'll be giving you more questions, but that questions you will be using to practice back at home, है ना? Then we'll be meeting tomorrow. Chalo. Meet Faisal. Hello, beta. Chalo, beta. Just 10 minutes we are having, so quick now. Secondary valency. Now, sir, Werner theory. A coordination complex was first made public to scientific community by a scientist called Werner. Werner is called father of coordination compounds. He was not very much accustomed with the splitting thing. That was later, crystal wheel theory was later developed, but Werner said that these coordination compounds has two type of valency. Primary valency, which is ionizable, satisfied by the oxidation state of the metal ion. Secondary valency, which is non-ionizable, that means which is there inside the coordination sphere, the ligands, the number of ligands, that means the coordination number decides the secondary valency. This copper pentahydrate, the blue color, copper anhydrous copper sulfate is colorless, white color. This is beautiful blue colored compound. Why? Because the copper cation gets interacted by 4 water as ligands, and once it gets 4 water as ligand, you obviously can see cobalt copper plus 2 will have 1 unpaired electron, so unpaired electrons will make it paramagnetic and will allow it to have color, and the color shown is blue. But sir, you have just made 4. Where is the 5th molecule? Sulfate. Because this is plus 2, so sulfate will be your counter ion, which is the satisfying the primary valency, and 1 water molecule with this plus, 1 water molecule will be attracted by hydrogen bonding. So this is water of crystallization. This is water of crystallization. So actually CuSO4.5H2O is Cu cation with 4 water as ligand and sulfate ion as counter ion, but with 1 water is acting as water of crystallization because that is attracted to the cation through hydrogen bonding. I hope everybody is clear with this now. So how many are secondary? Sir, secondary is satisfied by coordination number. How many ligands? So 4 ligands. And number of hydrogen bonded, that is acting as water of crystallization. So very beautiful. Perfect, perfect guys, perfect everybody. Moving to the next one. Now, beta, this color is very important. It is a color because of which NCERT gives you a picture that why unpaired electrons DD excitation can take place. So the example that NCERT uses is of nickel plus 2 cation. The nickel plus 2 cation with chloride ion, because chloride ion is a weak field ligand. As you start entering ethylene diamine, the color transforms, and that color transformation, actually NCERT used that color transformation to make us understand that DD transaction can take place, and because it is NCERT, so that color is also very beautifully used. You should learn that also beta, because for colors you cannot do anything. You should have to learn some mnemonics or directly those NCERT facts. My JEE students, they fear from it like a lot, but yes, you people are quite confident with NCERT reading. You know the process, you know the importance. So please remember this color. Actually, it is initially green. Once you start adding ethylene diamine, which is a strong field ligand, so the splitting gets more. As soon as the splitting gets more, you require more energized quanta of electrons to quanta of energy to get excite, and once you come back, you will release corresponding packets. So then it turns pale blue, then it turns dark blue or simply blue, and finally it attains a violet coloration. This is the happening of Ni plus 2 cation on addition of ethylene diamine, the ligand. A very famous color transaction beta, you should always remember this. Chalo. Moving to the topic of isomerism. Now, quickly summing up the topic of isomerism. Coordination compounds, just like organic compounds, can show structural isomerism also, and they can show optical isomerism also. The famous optical isomerism they show is geometrical and optical. Geometrical isomerism, the same thing, but yes, you have to learn some patterns of formula. So let us explore some questions to learn the pattern of formula which shows those structural and optical and stereoisomerism. So which type of isomerism is exhibited by these compounds? Now, chromium having 6 water as ligand, here 5 water as ligand, here 4 water as ligand, and every compound has same molecular formula. Some molecular formula same, structure different, as in it is structural isomerism, but structural isomerism arising due to what? Water sometime acting as ligand, sometime acting as water of crystallization. So this is nothing but solvate isomerism. Because sir, for geometrical and optical, you definitely should know the idea that molecular formula and structure also should be same. That means the ligands that are attached, they should not be changed, because that will change the structure. And that once molecular formula and structural formula is same, then only you can think of the stereoisomers. So obviously this is quite easy, attemptable. Again, sir, here this is having NO2. So what, sir? NO2 is an ambidentate ligand. sometimes nitrogen can also ligate, sometimes oxygen can also ligate. So structure will change, and because structure will change, so structure isomer, what kind of structure isomer? Linkage, because linkage is changing. So A is definitely 2. So this can be right or this can be right. Now for B, sir, here I have 5 ammonia and 1 sulfate. So B can be 4 or 3. B can be 4 or 3. Sir, ionization and coordination. Beta, for coordination isomerism, you need cation also and anion also. Both should have a complex cation and complex anion. Then only you can have coordination. So it can only have ionization. It can only have coordination or ionization. It can have ionization isomerism. Now, what is an ionization isomerism? That sometimes, like for example, here sulfate ion is acting as ligand. But sir, another structure can exist where chlorine can act as ligand and sulfur can act as a counter ion. Yes. So that isomerism is known as what? It is called ionization isomerism. That means B is definitely 3. That means B is definitely 3. So although I have ended up with an answer, but still, because we are learning, so here, so both cations and anions are coordination complexes, so they can definitely show coordination isomerism. And water, we have already seen, it is known for making a structure as solvate isomer. Yes, when solvent is water, so it is also termed as hydrate isomerism. So these are some type of structural isomers that you should know. Yeah. Now geometrical isomerism. The very famous geometrical isomeric forms are facial and meridional form. Now what is this facial form? Suppose I have this ligand of cobalt, where cobalt is, let's say this is in +3 oxidation state. So how can you make this FAC and MER form, sir? Now facial form says that if I have ligands and all the ligands have occupied one triangular face. Now what is that triangular face? This is that triangular face, beta. See, if they are occupying a triangular face of an octahedron, then such M A3B3 type of isomers are called FAC isomer. And if no one is occupying a triangular plane, how can you make sure that no one is coming on a triangular plane? By making any 3 of them on a equatorial plane. So this is called a meridional form or MER form. Both have same molecular formula but different 3-dimensional orientation, hence they are geometrical isomer. What geometrical nomenclature? FAC and MER form. Now what is asked in the question? The Cl bond in this facial form. Sir, Cl, CO and Cl. Sir, this is definitely a 90-degree angle. So this is definitely a 90-degree angle. That everybody through your VSAPR theory, you know this logic. I hope everybody is clear with this. Chalo. Now, again a facial meridional question. Now, chiral compounds from the following are, sir, now for platinum complexes, we know, sir, they are square planar. A square planar species beta can never be chiral. So coordination number is 4 over here, so it can never be chiral. Coordination number is 6, but it is trans. Trans will always have a plane of symmetry. So because of presence of element of symmetry, it cannot be chiral. Trans will always have a plane of symmetry. Who cannot have plane of symmetry? Sir, cis form. And here coordination number is also 6, so it is not square planar. I will be having platinum like this, and how this cis form is having no element of symmetry, because I have ethylene cis as in Cl on this side. Here I'll be having ethylene diamine. Here also I'll be having ethylene diamine. So here you will not have any excess of any element of symmetry. So therefore this will definitely be a optically active coordination compound complex. I hope everybody is clear with this. Now, moving to the last question, a very famous example, to inhibit the tumors. Remember the last 1.5 pages of coordination compounds, the application of coordination compounds in day-to-day life. The last page of NCERT beta, definitely please make sure you are reading it. In order to cure those tumors, what you need, sir? Platinum complexes. So every compound of platinum, especially cisplatin. Cisplatin is a platinum complex having ethylene diamine and chlorine. So that cis form of the square planar structure of cisplatin is actually a cancer treatment medicine, and therefore B and D becomes your right answer. Yes, option 1 is your right answer. Yes, beta. I have some more questions for you from P block also. D block mostly I have covered. So, and then yes, this is the homework that I wish to give you. Although I would rather say salt analysis, beta, you can leave also. But if you want to score 45 out of 45, then at least attempt these questions of salt analysis. I have specially segregated few questions. Yes, you will be requiring inorganic knowledge, inorganic revision. So because I guess this was the thing that I wanted to give you so that you can work on these questions yourself, and if you face any doubt, obviously we'll be meeting in my next class. And if you want me to come again with some of the topics of this inorganic side of chemistry, then after the live, now this is your job, all the serious students who are there, after the live, once the recording is there in the live section of PW NEET English channel, go to the comment section and tell me what you want from the, else I'll be starting with organic chemistry, what I have planned for you. But yes, if you want any revision of whatever topic of physical or inorganic we have done, because physical we have completed 3 chapters, we want more solution, electrochemistry and chemical kinetics, that I'll be doing on tomorrow's live with the 500 marathon questions. I'll be discussing those chapters with those relevant questions of PYQs. And inorganic, this is yes, if you have specific some more choices, no sir, teach this, so go to the comment section and I'll definitely be watching it so that we can help you to the best of our efficiency. Else from next week I'll be starting categorically organic, but yes, I'll not be coupling organic. I'll be taking a complete week and we'll be giving you organic in such a way so that mechanisms can also be discussed. Okay, so this is it from my side, guys. I hope you enjoyed the session because I did. Beta Nanya, don't worry, I'll be doing that, because organic I have heard got some few requests, so I'll be making organic I'll be making it short sessions, not these extended sessions, and we'll be doing that in bits and pieces, so don't worry. But yes, if you have any specific details or requirement just after the live, go to the comment section. I'll be definitely watching it. So this is it. Acha, thank you so much, sir, for your efforts. Okay, Ananya, thank you. Thank you, beta. You people are great. You people are great, and you people are awesome. Ultimately, you're working, and you're working for your own good. And by the way, if you perform well, we have got our reward. So your best result is our reward. Keep working, guys. Keep working, warriors. Bye-bye. We'll be meeting in the next class soon. Bye-bye. Anna?